So in this session, we are going to cover graph theory, and the full graph theory we are going to discuss, and only the specific topic. Those topics we are not going to into important. We are
So,
not
like
going to
once
discuss.
from whatever you're left after integration, you can give the subtitles of all the topics, and whichever is like doubtful, we can ask, sir.
So topic is not left only. See, week 9 also we have covered. Sorry.
No, sir. No, sir. I'm telling like after week 9, after the integration part, like if you could if you could just list out the topics where whichever topics were weak, we can ask that, sir.
Getting 6 here.
Then you can clear the doubts.
Because here, those two dice are rolled 2 times. That means you can see one dice rolled 2 times.
Please, if you can mute yourself.
Of the success will become getting success for 6, right?
Okay, so important questions type of integration. There are a lot of. So this is not any important. Like there are topics I can tell you, but yeah, important type of function is telling will be like it will be difficult. So that means you have I have just given to the solution exactly. There's no mean of such. I can tell you the topics. Yeah, weightage is graph theory and in last integration part have some more weightage in compare of what is the whatever the quiz 1 syllabus and quiz 2 syllabus are there. So what is the general attendance in the PYQ session, old QP discussion session? Because I am just looking here, very less attendance or very less people are only 27.
Hello, sir.
Yes.
Yeah, so what we gonna to discuss in this lecture, in this session?
In this session, we are going to discuss graph theory.
So will you explain topics with examples?
Yes, topics with examples.
Okay.
And I think the mock solution have uploaded, right? Okay, just check. Let me share my screen. No, the solution is not uploaded. My screen is visible to all of you, right?
Yeah, sir.
Please give us some questions related to graph theory. Is the topics to focus on?
Sir, can I ask some doubts from the mock test?
Yeah, what is your doubt?
I had a few questions that I didn't understand.
Okay.
Sir, I think we'll have only a doubt sessions if possible because graph theory was explained multiple times. I don't know, sir, like if
It's fine.
it's possible.
Okay.
Because week 11 and 12 have recently only done.
Okay. So
It's just my
yeah,
opinion,
okay,
sir. I
sir.
don't, I'm
But
not
it
sure
is
about others.
possible.
Okay. Yeah, so let's discuss with the doubts only. First doubts only, then the revision will go. Because in revision, I will going to cover. Okay, I'm just let me write that. So those will not take much time. So I am going to cover different type of problems in graph theory. So like vertices,
Sir, if you
edges.
take,
So
so doubts
okay, so
related to graph theory.
so doubt related to graph theory, and then adjacency matrix, and then even the adjacency list also we can, and then different type of problems, no? That
Yes,
is
sir.
independent set. I hope this all like this all very much clear to all of you. So if it is related doubts, then that would be good. So independent, and then vertex cover, and then the graph coloring, and then matching,
Yeah.
and then DFS. So DFS and BFS and DFS. So most probably in BFS, you should to focus on trees. DFS tree,
So these topics, please explain by
Dif,
examples.
DFS tree. Okay. So this is a DFS tree. And then here is topological. The next is the only this is and related to the complexity is of BFS and DFS is more focus on here. Then the next topic is the DAG is there. DAG, what is DAG? And DAG have two type of question: topological sorting, and then next is the long guest path. So this topic I will say important. The graph, I mean to say this topic
The
is
longest
important.
part, can you just explain the prims and crystals alone with an example?
Important. These topics are important. This topic is important in this hour for any one of you can assume that may come. Okay. This is also adjacency. One by one. Okay. This you can assume at least related problem on adjacency matrix or list. Then next is longest path, and then only I am going to discuss Dijkstra algorithm. Okay. Dijkstra.
Prims and crystals, can you also discuss, sir? Because
Crystals.
Crystal.
Dijkstra then so Dijkstra is for the shortest path only. So this is going to discuss that, and Belmont, Ford, or Floyd Versal, we are not going to discuss that. And then is a spanning tree. Okay. A spanning tree and minimum cost is spanning tree. which is have two things, Prince and Crystal. So Dijkstra is this is one important. This one Dijkstra you can assume, but not I will say so important, but yeah, this is important. This one is important. This is one. Okay, so these are topics we are going to discuss. And many times we have discussed, so we'll discuss by taking some problem with a random example, random graph I will take and then discuss that. So first I will take your doubt. So let me know your
Sir?
please raise.
Sir,
Sir, I just now joined, so I just want to know what are the things went till now.
Nothing is done. I just wrote topics.
Okay, sir.
sir, can you
Yes.
explain the 8th question of the mock test? I mean, not explain, but there's a doubt I have in the options.
Yeah. So okay. So please. So yeah, one by one raised hand. That would be good. Then we'll discuss with the this one. Okay. So okay, in the mock we have doubts. So just okay. Just a minute. Just give a minute. Okay. 1 minute. Then we'll take the mock.
Sir, are we going to see from week 9 this session? Sir?
Yeah, I also have doubt in that topic.
Sir,
I guess Sir is not there.
Yeah. Anyone know the weightage of end term exam?
If anyone knows, so please share with us.
yeah, I wanted to.
Firstly, this graph weightage. This graph.
Okay, 60% for 9 to 12 weeks.
Sorry for interruption. I just that's why I said just a minute. So weightage is, you can assume that 9, 10 and 11 is
Sir, your voice is breaking.
roughly, you can assume 40%. Okay. Is my voice is clear and better?
Yeah, now
Right. Sir, it is little bit breaking.
Okay, just a minute.
We got a mail regarding the weightage and it's 65 to 70% for week 9 to 12.
Yes,
Why
majority
did
are from those which are not
12
written.
not.
Sorry. So weightage is, you can assume at least week 9, 10 and 11 is, you can assume at least 30. I mean 30 means there 60 it will be. So 60 to 65. This much.
Sir, can you please tell all the important topics to be focused on in the first 8 weeks.
So all
sir.
topics. So the first thing I will say, all topics are important. Okay, all topics are important because the question you may get for each week, at least one question you will see in the intern. This is the life.
Sir, are we going to discuss from week 9 to 11 in this session?
Yeah, I also
Yeah.
have some.
So week 9 is almost done. 10 and 11 I'm going to discuss.
Okay, sir. Like in the last lecture, we haven't covered all the week 9 topics, no, sir.
No, almost we have covered. Riemann we have done, and also the integration part is just remain, and I also just wrote the what is the integration and what is the topic. If you see that in last if you
Sir,
have
your voice is breaking.
okay. Am I audible right now properly?
Yes, sir. Right now you are audible.
Yes, sir, audible.
Okay, so in the last I said that if you have a function which is in stepwise, so how you will do the integration, that is an important thing, and I have just given
Sir,
and
I have
I
doubt.
have given
I
some
have doubt
problem here
regarding
related.
that the grading, sir. So, sir, is it like 40% or is it the formula bias calculation?
So let me finish this one. So I have just given to this problem and related to this problem how to get the integration part. So that's the part only will remain. Even I have discussed that. So you can expect the similar problem. I also said that similar which is in the break stepwise. It is in the break form or even stepwise function. And this stepwise function you can assume.
Sir, is this recording in YouTube, sir?
So yes, it is live.
Yes, sir. Thank you.
Okay, so let me start the thing.
Sir, remaining weightage you didn't.
Okay, so weightage, yeah, okay. So weightage is I just said week 9 to 10 is I can assume 60 to 65, and then from week 1 to week 8 you can assume at least one question from each week. Okay, at least one question from each week. Okay, and weightage is now remain weightage is at least each question at least one question from each week, so you can assume that okay now the remain each week have equal weightage. Okay,
Sir, 18 questions in exam will ask.
not 18 question, the question will be not you can assume 14 to 15 question.
So, what is the qualifying the grade? Is it 40%?
Just go through with the document, grading document.
Sir,
40%
Sir, I
it is.
went through that, sir, but it is not stated clearly there.
So 40% is you have to pass first in the interim exam.
Sir, because some are saying the 40% and others are saying that it is 20. It is like the from the formula.
Yeah, so first you have to pass, then for a grade you have it will be the grading document, whatever in the grading document is written. So let me discuss with the doubts. So let me continue now. Otherwise, like you have many people have doubt only the doubts. So let me doubt with the related what we are going to discuss in this session. So like GI, Ahuja is the first one. So what is your doubt, GI?
Sir, I have a doubt in the 8th, 13th, and 14th question of mock test.
This one.
Yes, in this, the third and fourth options are both the same, and one of them is correct, but like the second option says that the company made loss in year 2013 only, and that is correct. But in the third option, it says that we cannot determine the losses. So both of them cannot be correct at the same time, right?
Okay, so just a minute. Okay, before discussing this mock, if you have mock doubt, okay. So just let me give here the mock solution just a minute. And then let me post the solution of the mock, then we can discuss. That would be good. Like once you see the solution and then ask your doubt. So even I have already said to the operational team, but they didn't uploaded the solution. Okay, so just a minute. Even let
sir?
me give here the
Sir, like before we go for solving the question, like can you discuss all the topics, sir, so it will be clear along with some questions.
All the topics are already discussed, right, in the previous revision sessions. Today is for only graph theory, sir. Side.
Like I mean, I'm asking the concepts about like week 10, 11.
Yeah, so that is week 10 for week 10 and 11 we going to discuss. So okay, I have posting the solution of the mock in chat, okay, to everyone who having doubt. First see the solution. I have already posted this one, okay, in the mock solution of the mock. Okay, please go through that, and also I am just a minute. Let me upload the solution in the graded, okay. Okay, so I have uploaded the solution first, okay. I have given in the chat also. Please go through that. And
Sir, the questions that I had a doubt in are not there in the solution. Like the questions are different.
Yes, sir, the questions are different.
Me too, sir. Questions are different.
okay. All questions are different, or some questions are different?
Sir, some are kind of similar, but most of them are different or are not there in the mock which we have been provided.
Yes, sir, there are 2 or 3 in which there's only the numbers that are different, but for most of them, the question is totally different.
Okay. Okay, so okay, let me finish first. Okay, let me finish the topics first. Then that would be good. Otherwise, the topic will not be finished. And the mock is just a minute. Okay, so what is your doubt here? What is your doubt? I just said, we'll go with the doubt first. So
Sir, most of us are here for revision session. Doubts can
okay,
be
so
taken
yeah,
in
I'm
TA
just
session.
looking. Yeah, I'm also looking that somebody's RTAs can be discussed. So yeah, okay. To tomorrow in the tomorrow session, also you will get the correct solution. Okay, so correct solution PDF. So please wait. Okay, and the TS will also going to discuss the solution of the mock. So let's do with the topic. That would be good, because yeah, that's the revising thing. And then we can discuss. Then after that, if you have doubt or related doubt, then I will take that. There
Yes,
is
sir.
no
The
issue.
remaining, if the remaining topics are discussed in this at the first, like it would be good, sir. Like all the topics will be cleared then.
in the next session, whatever the going to be, it will be first we will discuss the mock solution. I will tell to the TA. Tomorrow is one, no? Tomorrow is one session, TA session. You can
Yes,
see
sir.
it is. Tomorrow is on TA session, so in that you can discuss. So in the graph, so graph is actually the graph theory is actually generated. The reason is with the you can simply see with the routes, or you want to reach some cities, or even the aeroplane, as you have seen in the lectures, the routes of the aeroplane. So that is if you see, or even in the routes of the train, okay, railway paths are there. So if you see that, that is kind of representing between two stations, there you can assume there is an edge. And if you see the route of at least one city or two cities or one state, you see the route of the trains, so that could be represent a kind of graph. Or even the mathematical problem you can change in the graph theory problem. So like coloring of the you have seen in the series how to color the how to color, or how to color the that map, whatever the India map is there. For that, how to color, how to give the different color to the different cities. So even the mathematical problem can be changed in the graph theory problem. So from there, suppose if so the graph is like, you can think that these are, you can think these are the vertices you have, or even this, suppose this is the city, and this is the path you have, and this is the path to go to city C1, C2, C3, C4. Like you cannot directly reach to the city 4, you have to go with the city 3 and then 4. Or this is the going to be, or there is a direct path to city 3 to city 4. So this is a kind of representing a graph. So these are called edges, okay? And this is called vertices, okay? And there is there are the concept that a complete graph is there. So what it means that by the complete graph means what? Every vertices is like this graph is not complete, no? This graph is not complete. The reason is this vertex is not connected with the this vertex. So complete means every vertex is connected with the every different vertex. Like every vertex is connected with the rest remaining vertices. So like if you do by this one, now this is the completeness is going to be happen with the graph. Okay, so this is connected with the all, this one is connected with the all, this is also connected with all, okay. So here I just made it here, no, crossing, so you can assume like this. So outside, from the outside you can think. So this is now a complete graph. So suppose you have a graph, this one, or even let me erase this one, okay. So there are representation of the graph, okay. There are some representation of the graph. So like suppose this is the C1, these are the vertices. So we can different way we can write even. So there are two topics, there are two things. There is a directed graph and undirected graph. So this graph is undirected here. That means here you can, there is no direction is given. You can go either this way or this way. Both way you can communicate. So like you can drive your car, not only this is not one-sided road. You can think this is a two-sided road. So you can go either this city or you can come back to the same city. So this is undirected graph. So there are this is undirected graph. There are some directed graph also. Like you can think like this. To see that there is a direction is given. So these are the vertices you have, V1, V2, V3, V4, V5. So this graph is a directed graph, okay, or even this way and thing. So this is a undirected graph and this is a directed graph. Okay. So if you have a graph, so you can differently represent. So that representation is called, the first thing is called adjacency matrix, and another, there are two ways to represent a graph. First thing is adjacency matrix and another way is the adjacency list. So for adjacency matrix is that how we will write the, or how we can represent this graph via the adjacency matrix. So the okay, so let me finish this one first. So so this graph is an undirected graph, and how we'll get the adjacency matrix? So directly writing like this, C4, and this is C1, C2, C3, and then C4 we have. Now see there, this is a kind of in the form of, oh, here is, here, let me write it like this. Now C1, C2, C3, C4 you have. Now C1 with the same vertex, we cannot assume. So if it is like C1 is not, there is no edge between the C1 and itself, means there is no concept we are going to discuss, a loop kind of thing. We can assume that there is no edge between the same vertex. So in place of that, you can fill it 0, and where is an edge, you can fill 1. So like C1 is connected with C2, yes. C1 is connected with C3, there is an edge. So yes, C1 is connected with C4 means there is an edge. So there is no edge, you can fill it 0. Similarly, like C2, for C2 you can do, for C2, C2 is connected with all other vertices. So like except the C2, you can fill 1, 1 for all. For the C3, again for C3, you can see it is connected with all other vertices. So C3, except the C3 means here 0, you can fill everywhere is 1. Now for C4, see that there is, this is not connected with C1. So that means except the C1, in place of C1, you can fill 0, and for C4, you can fill 0, and except that, you can fill 1. So this is the adjacency matrix. This is adjacency matrix. Its representation is adjacency matrix. Here is for the directed graph, same way is will proceed, but you have to mention with the direction. Like if it is V1, V2, V3, V4, V5 have. Okay. And this is V1, V2, V3, V4, V5 we have. Okay. So V1 to V, so there is an edge. So this will start from V1. This is for outgoing. So outgoing means this is outgoing. So this edge is outgoing for V1, but the same edge is in. So incoming edge, you can say. So incoming edge for V4. Okay. So this is outgoing edge, and for V4, this is incoming edge. And so there is two concepts for the undirected graph. The degree is there. Okay. Degree means degree of a vertex. So degree for a vertex C4, you can so degree of vertex means number of edges connected with this vertex. So here is 2 edges is connected with the vertex C4. So degree of C4 is 2, but degree of C2 is 3. Degree of C4 is 3. Degree of C1 is again 2. So there is no concept in degree and out degree for the undirected graph, but there is a concept for the directed graph in degree and out degree. So that's why I'm saying outgoing edges means here though it is there is a outgoing edges means out degree in degree is there. So in degree for V1 is 0, but out degree for V1 is 1. As you can see it here, there is no incoming edge, only the outgoing edges are there. For V2 in degree is what? In degree is 1, incoming edge is there 1, and outgoing edge is also 1. So in degree is 1, out degree is also 1. For V3, there is no in degree is 0, but outgoing, out degree is what? 2. For V4, there is no outgoing edge. So outgoing or out degree is 0, but in degree is, so out degree is 0 and in degree is what? 1. And for V5 there is no again outgoing edge, so that means out degree is 0 but in degree is 2. So this is the degree related, there is word out degree, in degree, this is the meaning of that. And in the adjacency matrix, this row is actually says that from V1 to, this tells you the direction, this is the direction from V1 to V2, or what is going to be the edge. So outgoing here, for outgoing edge means from V1 we have an edge to V4 and no other edges are there. So from V1 to V1 it will be 0, or even for all, only for V4 it will be 1 and rest all will be 0.
Sir, today we are discussing week 10 and week 11, no?
Yes, yes. For V2 is this one. So V2 is again, V2 have outgoing edge is this one. So from V2 to V5 we have, so V5 have an edge, okay, and there is nothing. Outgoing edge, see that this, there is an edge, but we are not going to write here one from V2 to V3 because this is the direction from V2 to where it is there. So from V2 to V5 is 1 and rest all will be 0. And for V3, so see that for V3 it have V5 and V2. So for V3, V5 is going to be 1 and V2 is going to be 1 and rest all are going to be 0. Okay, so see that this is the difference to writing the adjacency matrix. So this is the direction tells you from V2 to which edge is, which vertex it says.
Excuse me, sir.
Yes.
As you said, in directed graph, there's in degree and out degree. In degree and out degree is also in, I think, in undirected graph.
No. So that's why I said there is no concept for undirected graph in degree, out degree. There is only degrees there. But for the directed graph, have the in degree and out degree concept.
Okay, means there's no any concept of in degree and out degree in undirected graph.
Yes.
Okay.
Okay.
Sir, this disconnected graph.
Okay, so yeah, okay. So disconnected graph is there also. Connected graph means there is no vertex which is not connected with the other vertex. That means every vertex is connected with some vertex, or even this is not a proper word. You can reach. So there is a reachability. So suppose you have a graph. Okay, let me write here. So this is the graph. Suppose this is the graph you have. So there is a reachability thing. Suppose this is V1, V2, V3, V4, V5, V6, V7, V8, V9. Suppose this is a graph you have. So connected graph means what? You can reach out from V1 to any other vertex. But here is not the case here. Like from V1 you can not reach to V9, vertex V9. So this is not a connected grid. This is not a connected graph, not connected graph. This graph is not connected.
So
but
all
if
the
it is,
vertices should be connected to all the vertices.
no, all the vertices is not is connected with all vertices. No, there is a, you can
That is
find
complete.
so even for every vertex you can find a path to reach out some other vertex. Always there will be a path. So like if I connect like this, so now this is a connected graph. This is a now you can now reach to any other vertex to any other vertex.
At
Sorry.
least it should be connected with at least.
So here is, so in the terms of reachability or in terms of path, you can think that from any vertex to other vectors, you can reach out. Okay, so this is the meaning of connected. Otherwise, if you are unable to reach out the other vertex from any vertex to any other vertex, then it is not a connected graph. Like here, this is now connected. Otherwise, if I remove this one, so this is a disconnected graph, not connected or disconnected. Consider.
So there is
Now there
also
is-
a graph called matlab, like all the vertices should be connected to every other vertex, like directly.
So that is complete graph. That's why I just now said, no, complete graph thing.
Okay, sir.
Complete graph. Okay.
So complete means where?
Sorry.
So can you just give one line for complete, sir? Like I remember, but I just forgot it.
So I just said each vertex is connected with the other
Yes.
all vertices.
Yes.
So that's it. Just now I said, and I spent time there. I just spent time there. So I will suggest you again go to back to the session, because let me finish this thing. So this is a connectedness and disconnectedness. So adjacency list is there. So adjacency list again for the undirected graph. So you can write here adjacency list means just write like you can list out the vertices. So C1, C2, C3, C4. So C4 is there only. So just list out that. So list out that, and if it is there is an edge, C1 is connected with what? C2 and C3. So C2 and C3. C2 is connected with all other. So C1, C3, C4. C3 is connected with all others. So C1, C2, and C4. C4 is connected with C2 and C3. So C2 and C3. This is the list. This is the adjacency list. So this side is actually, so here is in the bracket, you can write in the middle bracket. Okay. In the middle bracket, this tells you that C1 is connected with the C2 and C3. C2 is connected with C1, C2, and C4. Sorry, C3 and C4. So this is the adjacency list here. Like here, for this one is suppose V1, V2, V3, V4, V5, V6, V5 only we have. So list will be what? So list will be V1 is connected only. So this is a directed graph. No? So V1 is connected only V4. So this way, whatever the outgoing edges, by this way you can write. So this is going to be V4 only. V2 is connected with
V5.
There is incoming and outgoing. So but V5 only you will write. For V3 only you can write V2 and V5. So this is the process to list out that. So this is again, you can defer that this is a directed. This is for directed graph. So there are two representation by adjacency list. Okay, this is the list or adjacency matrix. Using the adjacency matrix again. Now once we done with that, so there are different type of problems which is coloring, graph coloring.
So one basic question that I want to clarification on. Most of time it is asked that number of edges is given, then they ask for how many nodes are possible, and nodes are given, then ask for how many edges, maximum edges are possible. So can you clarify on those based on these two type of graphs, directed and undirected? How to calculate that?
So maximum, like there are some problems. Suppose you have given 5 vertices. Okay. Suppose you have given that 5 vertices. How many?
Sir,
How many?
Sir, there is a problem on this topic. Can you from graded assignments 11? Question number 2 and 3.
Okay, so let me finish this one. So suppose you have in a graph which have 5 vertices in a graph which have 5 vertices, then how many maximum possible edges could be. Okay, how many maximum possible edges this graph have. And or let me write, this is one problem. The second problem is how many minimum number of edges, how minimum number of edges will be how many minimum number of edges will be there. Okay, will be there. Okay, so that the graph will be connected. At least connected is needed, so that.
So this is for
most
directed or undirected.
So most of the time there are also a kind of variation of the first question. Like it will say there are 7 in degrees at most and like 5 degrees at least. So how to solve that? Those.
So at least 5. So that's why I wrote, no, at least we needed how many minimum number of edges we needed so that the graph could be connected, and how many maximum possible edges. So suppose in a graph there is nothing written in the undirected and undirected. So if there is not specified, it is not specified that for directed or undirected. So always you can, by default, you can assume that that problem is for an undirected graph. Okay. So by default, whenever is such thing is there and nothing is, you don't have any information is given. So by default, you can assume that that is for undirected graph. Always. Okay, otherwise, it surely will be specified there that it's for the directed graph. The problem is for directed graph.
Sir. Like in the first question, like there is constraints. Like the one vertex must have at least 7 edges or at most 6 edges. So, sir, that kind of question.
That is different question. This is the basic one. That is high level question.
But in assignments, there are like those type of questions.
That is different question. I just said if you don't have any information about the graph, you can by default. So let me finish this one. If you don't have any information related to saying to be that is graph is directed or undirected. So by default, you can assume that that is going to be. Okay, I think my voice is breaking. Is that clear now?
Now it's okay, sir.
Now it's clear, sir.
Okay, so if you don't have any information, then you can assume that is by default that is for the undirected graph. So now let me talk about what is going to be the maximum possible number of edges. Yeah. So what is going to be the maximum possible number of edges? Can you tell me? How we can calculate this one?
The formula is
what is going to be
n
that?
minus 1 by 2. Hello. So got disconnected.
Yeah, am I audible right now?
Yes, sir. Now audible.
Yes, sir.
Okay.
Yes.
Okay, so what will be going to be the maximum number of edges?
So formula is n into n minus 1 by 2.
N into n minus 1 by 2 for the maximum number of possible edges. Maximum number of possible edges, I'm saying. N into n minus 1. Okay. Okay, so yeah, there are some formulas also. If it is, or either by this way you can think. Okay. By this way you can think that, see, for V1, if it is this vertex is there, so maximum possible edges means it should be, that means it should be complete graph. Okay, complete graph. Maximum number of possible edges means it should be complete graph. Complete means every vertex is connected with the other vertex. There should be an edge between the any two vertex. Any two vertex, there should be an edge. So like V1 should be connected with all other. V2 is going to be connected with all other. V3 is going to be connected with all other. V4 is going to be connected with all other. This is one, this is one, this is one, this is one. V5 is going to be connected with all other. So this is done. So this is, we have, this is V1, V2. Now you can count that. So, that's the meaning here. So what is the formula? N into n minus 1, that is 5 into 4 is going to be 20.
N minus 1 by 2.
Sir,
N minus.
If we take 4 edges, then only 4 nodes, then only 6 edges are possible.
So like you can count, no? You can here easily you can count, like for V1, you can also count that for V1, how many edges going to be? 4. Similarly for V4, how many edges going to be? Sorry. So for V1, how many edges is going to be from V1? This is going to be 4. For V2, how many edges are there? How many edges are going to be here? This is 3, right? Except you had already counted for, right? You have already counted for that for V1. Now for V4, you have, for V3, you have already counted 2 1. So this is going to be 2. Okay. And then again for V3 is then for V4, we have already one counted. This is going to be 1. And I think I am missing something. So that's why it is going to be n minus 1 by 2 kind of. Okay. For the complete graph, maximum number of possible edges, by this way you can, like this is for V5 is going to be, and for other like it is, if you have n vertices, then you can assume n into n minus 1 edges by 2 is needed for the complete graph. And now for this to be connected, how we can assume that to be connected? I want a minimum number of edges so that the graph should be connected. So what is that going to be? What is that going to be?
Formula we use n minus by 2 or n?
Oh, so this one, and not this one, this one.
For first problem.
Yes, for the first problem. Okay,
sir. Sir, in the graded assignment number 11, can you solve the first question?
Can you go through the solution? I have just uploaded the solution first. Okay, so let me finish with the revision thing. Okay, whatever I am discussing, let me finish that one. Okay, at the end, if you have doubt, then we can discuss. So can you tell me how many edges so that graph should be connected? I just needed minimum number of edges you want. What is that?
5. I think n minus 1 is the formula.
N minus 1.
So, and what is that? In that case, what is going to be the graph? There is a specific name for that? What is going to be that?
That is directed one, I think so.
No, not directed. For undirected.
Panning tree.
Yes.
So we can't repeat the connection, sir.
Yeah. So there is a
undirected. So we can't repeat the connection. For example, V1 we take from V1 to V3. We can't take V3 to V1.
Yes. So that's why only just we needed connectedness. So that means here that there is one term is related, that tree. Tree is actually the minimum. There are two definitions. You can say for tree. Tree is a what? Tree is a graph which don't have any cycle. First thing. Another definition you can say tree is a minimum. You can say there is another definition is tree is a minimum, or tree is a graph which is connected and having the minimum connected, something is there, minimum connected graph. That means that it should be connected and minimum possible number of edges. There are two definitions for tree, you can say. So this is we are talking about for tree. So this is another way to say tree. So for tree, if you have n vertices, say n vertices, then number of edges is going to be n minus 1. So for the how many minimum possible number of edges will the graph to be complete, so to be connected, how many minimum number of edges could be there for the graph? The condition is the graph should be connected. So for that we have found 5 vertices, then it should be 4, at least 4 edges we needed. That is going to be the minimum number of edges, so that the graph would be connected. Still the graph would be connected. If you remove any one off, then the graph will become disconnected.
Okay, sir. So for the point 1, is there any separate calculation for directed one?
So for directed, there are many, like by this way also you can think, no, whatever by
Sir,
this
your
way
voice is breaking.
I just given that, okay, thing with the number of edges connected with that and make a formula like that. Okay, is my voice is better and clear? Is that better now?
Yes, sir.
Yes,
It's
sir.
better.
Yes, sir.
Okay.
So can you repeat?
So for the undirected, you have to think like I don't now itself. This time I'm not getting the problem. For the undirected is, see, the undirected graph is needed more information. It is not directly in the one word it will be completed. It will needed some more information, that which vertex we are going to talk about, connected or not connected, outgoing, incoming. So some more information should be needed. For the undirected, easily in one line you can think, but for the directed there would be a problem. So that's why I said, if the problem there is no information is given, then by default you can think that is going to be undirected graph. Okay, so let me move ahead and let me tell about the graph coloring first.
So for coloring graph, we need to find the directed or undirected graph, is it?
For the coloring graph is again for the undirected graph you can think, and even in the generally for the undirected graph we can think that. Okay, for the directed is again it's depend on the problem, that how the problem is asked.
Okay, sir, thank you.
So like suppose again here you have given a graph again, and we want to find the how many colors is needed to color this graph. Okay, again by this problem it will be very much clear. So how means minimum number of, so this problem is we want minimum number of color so that we can color this graph, means we can color the vertices. How many color is needed to color the vertices? And the problem is if it is color with this green color, then it should be not, means you cannot, or now whatever the outgoing edges, I mean whatever the edges connected with that vertices, opposite of the vertices you cannot color with the same, like this you cannot color with the green. Okay, this is the problem. So how many color is needed, we can think that. So like for this one, if you suppose you color with the color 1, so by I'm just giving the name, if you are coloring with this one, then you cannot color with this vertex with the color 1. Okay, but you can color this one. Once you color this vertex with color 1, then you cannot color this vertex, but you can color this one. Okay, and if you colored with this one, then you cannot color by this one, but I can color this one with 1, and also this one. So see that, so this is 1, this is 1, this is 1, this is 1. So this is by one color is done. Now that you can take the second color, which is here, just color this one. So this is colored, now it is already 1. Okay, these are the already 1. So Now you can color this one with the 2 and this one with 2. Okay,
Sir,
now, yes.
can you please solve questions related to the mock test?
I have just given the solution. Let me finish this. Are all of you want to finish whatever I'm doing, or I just will take your doubt first?
You are doing.
What you are?
Sir, please continue.
Sir, just please
Sir,
continue. Please,
Let
please
me
complete the
finish
revision
this
part
one,
first.
then I will take your doubt.
Yes, sir.
Sir.
Okay.
At the end of this.
Sir, please
Yes,
continue. Don't
I will
divert.
first. So this is going to be the second color. Now see that the next is only one vertex is remain. So 2 is already here given. You cannot color with the 2 here. So this is going to be 3. So see that there are 9 vertices, but only the 3 color is needed to color this graph. That's all. So at least 3 color is needed to color this graph. So this is a graph coloring problem. Here I just given the color name with 1. Okay. 1 is given. Otherwise you can give the different color. Okay. You can give the here is this one and then this one, then this one, and this one, this one. Now we can give green color to here, 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 and the next color is you can give pinkish, this one. So this is a graph coloring problem. So this is why while looking the graph, there is no formula. While looking the graph, we can color that. So the next is, the second is vertex cover.
The color of vertex don't match in one line.
In one line, yes, that's the graph coloring thing. So again, let me.
Excuse me, sir.
Yes.
Can I ask?
Yes, yes.
Related to graph.
Yes, yes.
I saw in a PPT, one question.
Your voice is breaking. For me, your voice is not clear.
Okay, now it's clear.
Okay, could you tell now?
Hello.
Yes, yes.
Now it's clear.
Yes, yes.
Okay, sir. So I'm saying in a PPT, I saw one application of graph coloring is a task managing. There's a one question given. Task managing, sir.
So if you have remembered that problem, you can tell me. Otherwise, let me finish this one. Yeah. So the problem is actually can be converted in graph coloring. So that problem is task management. No, so I think the problem is there are some tasks and we need to allocate, or we have 3 people or 4 people, or how many pupils needed to allocate that task, and there should be a connection between there should be a connection between the tasks. So, okay, maybe such problem can be converted in the graph coloring. You can mute yourself because background noise is coming. I don't know what is that. So this is now think that this is a graph you have, and I want to cover our minimum vertex cover means vertex cover is there. So vertex cover means the same thing. It is very similar that with the word with the cameras, you can, whenever such problem is there and any problem is there, you can think to have a graph and I want to cover. Here is vertex cover means not covering the vertex, covering the edges. Okay, vertex cover means first you need to clear that covering the edges is there. Okay. Now, if you have this graph and you can think these are the rooms you have and these are the corridors you have, and I want to install some cameras. So how I can install, or how I want to install some cameras so that minimum number of camera would be installed and which also cover the all edges. You cannot skim. So minimum number of vertex means we need those vertices, or we need those type of those vertices which cover the all edges. That is we want. So that is the minimum vertex cover. So like here, so you can think with the installation of the cameras. So like you can install here the camera. Okay, you have installed here the camera, then this will cover this edge, this edge, this edge, then this edge. Okay, these 3 or 4 edges is done. Now if you install here the camera, okay, This will
So
cover
which
this
topic
one.
is this?
This is minimum vertex cover. This is the different type of problems in the graph. Okay, the second lecture of the week. Okay. So if you install here camera, then this vertex is done, this vertex is done, but this edge, sorry, this edge is done, this edge is done, but here is remaining. Okay.
Sir, actually, your cursor is not visible, so it's very difficult to follow.
Again, okay. Till this time also, from the starting, it is not visible.
So it is visible, no issue, sir.
It's visible.
Okay.
So no, sir, but here is showing this side and the vertex. It's now it is difficult to follow.
So again, so please check your internet connectivity, that because for others is visible, then it is fine. So now if you install here camera, then this will be covered. So this 1, 2, and 3. And for the separate one, we needed at least one. Here is 4. So at least 4 cameras is needed. So 4 vertices we needed to cover the all edges. So that is called the vertex cover. So minimum number. So
vertex
again,
covers V7, right?
Sorry?
So second camera covers V7, right? We don't need third.
So second camera, not V7.
Again.
Yeah, I will again explain. So second here, the second camera not covering the V7. Here is the meaning of covering the edges. So yeah, that's why many people. That's why many people have got confused that vertex cover means they are used to think that covering the vertex. Here is vertex cover is covering the edges. We want those vertices which cover the edges. That's the vertex cover. So here this camera will cover this edge, but still this edge is not covered by any. Like I need at least one camera here which cover at least. Either it could be here or it could be here. Okay. So first thing, if you install here the camera, okay, this will cover this edge, this edge, this edge, and this edge. Now if you install here camera or any other camera, like if you install here camera, so the second camera is here, this one. Then this will cover this edge and this edge, but still this edge is remain to cover. So at least we needed either I can install here, I can install here. Okay, so you can install here. So this is V1, this is V2, then this is V3. This will cover now this one, and here to cover this one, any one of the place you can install. So we needed at least 4 vertices which will cover the all edges. So this is for the vertex cover.
Sir, minimum vertex cover, isn't it like similar to MCT? Minimum cost?
No. There is a weight is given. No, here is there is no related the weight word. Here is exactly covering the vertex.
Yeah, exactly. If not weight is not given, but task we are performing is similar.
So what we are doing there? What we used to do there? We are trying to find the minimum cost spanning tree. The spanning tree we want.
Yes, but we are touching every node in that also.
Every node, okay. So that is the for tree, no? That is for tree. So here, see, this is this a spanning tree? The first thing, is this a spanning tree? Is this tree first, or it is? If once you do that, is this? Here we are trying to find the vertices. There is we are to try to find the first spanning tree. Then there is MCEST there. Then there is a weight word. But first we have to find at least tree. But there is no concept related to the tree or something. Here just we are trying to find the vertices which cover the edges, which we from there we can look the edges.
So,
okay.
Can you give us some real-time examples, for this type of, like, how is this, where is this applied?
So simply applying, that's why this one is a real camera. No, these are the rooms are there, these are the corridors are there, and you want to install some camera. Even I'm speaking with the real-time example. You want to different, then we are not going to cover the syllabus first. Yeah.
Sir, in this graph which you have drawn, sir, like in this the minimum vertex cover is 3, no, sir?
Minimum vertex cover is 4.
Oh, 4, okay.
So four cameras we needed, four vertices we needed to cover all edges.
Okay, sir.
Now there is another concept. So same graph I'm going to take. Okay, this is the graph we have, and there is one word independent. Independent set is there. What is the definition of the independent set is there? Means here, independent set is a set which contain the vertices. Okay, which contain the vertices, but there is a condition that if you are making a set using the vertices, then you cannot choose those vertices which are connected. Okay, like I'm making a set. I'm making here is V1. I'm making a set V1, V4, okay, V9. So this is an independent set. This is an independent set. There are many possible independent sets, but this is an independent set because V1 is not connected by V4. V1 is not connected by V9. Okay, V4 is not connected V9. So there is no connection in between any these three vertices. So in these vertices. So this is an independent set. So there is a problem on that anyhow some problem you can convert it in the graph. Okay, anyhow you have some problem and you have converted in the graph, and that tells you that what is going to be maximum independent set. Maximum independent set. So here this one is not maximum. I can add some other vertex which is going to be also an independent set. So what is going to be the here maximum independent set means we want as much as possible vertices, but still there is no connection. There should be no connection in the edges. In the vertices. So let's find it here. Like I suppose V1 I choose is okay. I am trying to find the maximum independent set. Okay. So I suppose I choose as V1 first vertex V1. Then I cannot choose V2 because this is a connected. Okay. This is a connected with the V1 is connected to V2.
And we say that choosing those vertices which are sharing an edge.
So no. So we are choosing those vertices which are not sharing the edge. Not sharing the edge.
Yes, sir. Not sharing the edges.
So like then you can choose V4. Once you have chooses V4, okay. Then
V3.
Then if you choose V3, okay. If you choose V3, so if you choose V1, then you cannot choose V2, but we can choose V4. You can choose V5 also. V3 also. Okay. But now we have to very carefully have to choose. So now if you choose V7, then we still V3 is connected. If we choose V6, then it is connected with V5. Then we cannot choose these all. And above whatever the possible we have chooses. Now once we choose here, so this part is done. Above thing is done. Now any one of them we can choose here V8. So see that it is an unconnected or disconnected graph, but still the problem can be generated can be found. So this is going to be an independent set, but is this maximum independent set? Except this vertex, okay. If you add any vertex, let's add any vertex here in this set. If you add any vertex, then it is going to be not independent. Now you can verify that. In that case, now it is going to be an maximum independent set. If you add any other vertex, V2, V5, V7, remaining, whatever the remaining, except this one, if you add any other vertex, this is going to be now not independent. So that's why it is called maximum independent set, you can say. So what is the cardinality of this maximum independent set is 1, 2, 3, 4, 5. So cardinality of maximum independent set is 5. Sorry, here is 5. So such problem can be asked.
So here we are seeing that vertices which are not directly connected, then we will add in the independent set.
Yes. Now there is the same problem. I'm just next problem I'm writing. So this is a different type of problem is there in the maximum independent set, vertex cover, graph coloring, and that is now next is the maximal matching. So even the matching thing. Matching thing means what again? Matching is different thing. We are trying to find even the just stick on the graph here. For the real life problem, you can very clearly you can see the video that okay, and also you can not assume, at least in real problem you cannot see in the grade in the in-term exam. Okay, there is no real time problem, and just graph there will be given and direct question will be. Okay, so don't worry with that. If you want to see what are the uses, or is there any use of independent or covering or coloring, so just see the lecture 2. Every one example have discussed, okay, within a real life example. So here is maximum matching means we are trying to find matching means we are trying to find edges here. Here is again not vertex thing, edges. Edges means if you choose this edge, okay, if you choose this edge, then you cannot choose those edge which is connected with this one or this one, vertex v2 and v3. That means you are choosing such edges which don't have, here independent is sharing vertices. Means here is what happen if you choose any two, if you accept that if you choose any other vertex, there is a connection, there is an edge going to be. But here is if you choose an edge, here we are trying to choose edge. Okay, matching means you are trying to choose edge, okay, such that if you chooses an edge which will not any two, they don't cover the, they are actually they will not share the vertices, like this one. We choose this one, and you can, if you choose this one, then see that these two are not sharing the vertices here. They are not sharing the vertices. Okay. And again, if you choose this one, they are not sharing the vertices. Then these three edges are actually not sharing the edges. And then if you choose this one, so this is a matching. So matching is actually collection of edges. So v2 v1 v2 is an edge, v5 and v4 is an edge, v3 and v7 an edge, and v8 and v9 an edge. So matching is actually collecting the edges such that they don't share the they don't share the vertex here, vertices. But see that this is not a perfect matching. Okay, we chooses a matching, but this is not a perfect matching. Perfect matching is, see that there are how many vertices you have? 9, but we chooses 1 2 3 4 8 vertices is done in this matching. So this is not a perfect matching. We have to choose perfect matching means we have to choose such like that the edges so that all vertices should be covered. If it is not curving, then you can say that that graph is not actually the perfect matching. That graph don't have the perfect matching. Like this one, if you try to choose, this graph don't have the perfect matching. Anyhow, some vertex, any of the vertex will surely remain. If you try to see that, so this graph don't have the perfect matching. Okay. This is the related to the matching word, matching.
Sir, can you just explain the perfect matching ones?
So perfect matching means here is, see that I chooses this edges, no? So even here you can see that this is this edges actually contain the vertices, 8 vertices, right? This edges actually contain the 8 vertices, okay? But we have 9 vertices. So can we have a such can we choose such edges which cover all vertices? Cover means which include the all, anyhow contain the all vertices. This is not going to be able. So there is, you can make like that. If you have a,
you can draw a hexagon and you can have a perfect matching.
So you can see this is actually the number of odd edges is there. So if you have even number of edges, then possibly you may get a perfect matching. Sometimes there is also not possible that we cannot convey, there is no even, or even if you suppose like this, if you do this one, suppose this is the, or even or by this way, no. So I don't know how it could be, but it will take time. So I'm just explaining, this problem will be given similar to. So, but you can skip, you cannot expect problem on this matching. I just given the concept here. So let me move ahead because half of the time is remaining. Okay. In our, so next is the BFS and DFS is there.
Excuse me, sir.
Yes.
So in this graph theory, like you were given a question in mock test, right? Like number of cabs. So like when we assume ages to be people or places, right? So can you explain the topic with that question? So like how do we actually calculate number of cars? Like
sorry. Could you repeat, please?
So can you explain that topic with that question, sir? Like mock test. Like there is a question, right, sir, in the mock test for maths. And there was the question asked us to find the number of cabs, like the minimum number of cabs, like when we assume edges as people and when we and in the next case we assume them as these.
So okay, so the thing is you are not getting how to solve that.
Yes, I got answer for one, but I could not find the answer for others. So can you like just explain that while you're at this topic? Like it's the last.
So let me
question
finish this one. So let me finish this one. And then this is solution I have already given, but solution is not the perfect solution.
Yes, sir.
Can we discuss in the last
sure,
ones?
Sir.
Let me
Sure,
finish
sir.
this one.
All right, sir. Sure, sir.
Okay, so suppose this is the graph we have, and BFS is breadth first search is there. Breadth first search means this is an algorithm, and algorithm means this algorithm is actually for analyzing the graph, but there is a one way to analyze. So what is the way to analyze that is what is the way? So like here, analyzing means suppose I am trying to do this algorithm from the vertex 8. Okay, from the vertex 8. In this algorithm we have to start from some vertex. So I just chooses or I have started the vertex from the vertex 8. Okay, and the problem will be asked which of the following is the BFS tree. Only this topic is going to ask. Okay, we are not going to talk about the labels or those are we are going to skip. Only the problem is what is the BFS tree? We have the graph is given. What is the BFS tree for this graph? Okay, and what is the BFS tree? If we start from vertex V8, from the vertex 8. What is the BFS tree is going to be? So BFS tree is actually sees the possible thing. Like if you start from here, okay, from V8, let me write here from V8. So I can see vertex 9, I can see vertex 5. Okay, so here it is called visiting the vertex. I can visit vertex V9 and V5 from V8. Now, once you visit the vertex, let's explore the vertex now. So if you explore the vertex here, so one by one we will explore. First, whatever we did from V9, whatever the visited we have to finish that exploring. So first we visited V9 or even V5, we can do that. So let's assume from V9 I'm just doing. So from V9, let's explore. So exploring means again from V9 what we can see. So from V9 we can only see V8. There is no other vertices. So that means you can skip here. So there is no, we have already done with that. So we are not going to explore V8. So let's move on to V5. So from V5 we can visit V6 and V2. Okay, I can visit V2 and V6. Okay, this is the part we have. Okay, so and the first, so this is called this is called the level 0. If you say the level 0 means from where you started, and this is called level 1 means from level 0 to level 1 we have seen. Okay, now from level V5, this is the level 1. So from V5 we are done. If you are talking about the level, otherwise there is no meaning. Slowly, once we are going to discuss this breadth first search, you will get that what is the level. So what is going to be the level for V6? This is of level 2 because from now V5 we are actually exploring. So these are going to be the level 2. Okay. So let's start exploring V5, V6. So from V6, from V6 we can see here V5 and V7. Okay. So V5 already done, exploration or visiting we have done. So let's visit the new vertex, which is here V7. Okay, V7 we have. Okay, this is of the level 2. Is these two are level 2. Okay, from V2 is done. Sorry, from V6 is done. So now we are not going to see from V7. First, we have to finish that level. That means here we have to finish V2 also. So from V2 we can see V3, we can see V1, and we can see V4. So see that from V2 many vertices we can see. You see, so this is from V2 we can see V3, V1, and V3. So these are all. So V2 have level 2, no. So these are all fall under the level. So you can increase. Sorry, you can increase the one level from the V2. So this is all under the level 3. Okay. Now level 2 is done. So this is of level 3, is it? So this is level 3. So level 2 exploration is done. Now let's start exploring V3. Level 3 vertices. So if V3, if we do that, already all things have done. From V1, if you do that, already V2 is done. There is no other. From V4, if we check, already every vertices is done. So this is now a BFS tree. This is a BFS tree. See that this is a tree. This is all the connected. All vertices is connected. Okay. All vertices is connected and there is no cycle. So this is a tree. So algorithms give a tree. The same vertex, let's do a BFS. Then you will much clear. Then you will easily see that. So here itself now I will do. Okay, again the same. From the same vertex, we are actually going to do DFS. Depth first search.
Excuse me, sir.
So depth first search is exactly. Yes.
Sir, can you just again repeat the levels? Only the levels part.
So level part is from where you are starting. You can assume you just give the level 0. From where you are starting. Okay. And okay, whatever the vertices you are looking, just give the level 1. Okay. Like from V8, we can see V9 and V5. So that's why it is level is going to be 1 or V5 is going to be level 2. Now from V9, there is nothing that is already done. Everything is done. Exploration is or visiting. There is no new visiting vertex. But V5 we can see. From V5 we can see V6 and V2. So whatever the level it have, no, just add for the whatever you are looking from V5. That means I'm looking V6. So add with the previous one. 1 plus 1.
Sir,
1 plus 1.
Sir, in this BFS, like we have started from B8, no, sir. Like instead of that, we can start from B1 also, no, sir. Like
any. The problem is in the problem it is wrote, na? In the problem it is given that from B8. So maybe it said in the problem that start from B3. So how the problem is given, according to that we have to. Okay, means sir. In the problem which is starting point, the problem had chosen. Okay. In the problem which vertex, it says that start from there. So leveling is done. Is that clear? Leveling, how the leveling is I'm doing. From the previous one, which vertex you are able to see, that is going to be the level increment. Like this one is actually 0 plus 1. 1 increment. That's why it is going to be 1. This is 0 plus 1. That's why it is going to be 1. Then increase 1. And like from V3, so from V2, I can see vertex V4, V2, and V3. So what is the previous level from V2, which is level 2? So, and from where we are able to see that is going to be 1 incremented level. That means 2 plus 1. Each time we have to increment. That's just 2 plus 1. 2 plus 1. I think leveling is how the level is I am doing. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So, and there is no level thing in the DFS. Okay, there is no level. So in the DFS for search, there is no level thing. There is some different pre and post number is there. I'm not going to discuss that. Only just I will do it here for the DFS tree. So again, I am trying to discuss again I am starting V8 because the problem is again I am just DFS I can write here, find the DFS tree. So for starting vertex assuming to be V8. So let's do that. So
Sir,
DFS
can we start from any other vertex like for a different?
So let me write
two.
from the V6. Let me write from V6. So here is V6 I just wrote. Okay, from V6 we have to.
Yes, sir.
Okay, now DFS is exactly doing on the surfing on the internet, the same Google or anything. You know, you just go to the Chrome and search that what is this DFS. So what is the DFS or what is the VFS? If you write in there, then it will give many lists. So in the Google Chrome, you just go there and write DFS. Then it will give the list of DFS algorithm. So what you will go to the first page or even the second page or the second line. So just assume that you reach to the first line and there are different algorithm is written. So you just go to the second algorithm and do that. And once this page is done, you will start backtracking. Like here in the previous page, you cannot directly jump to this one. You have to backtrack. Means you have to go previous, then previous, and then previous. So, but here, once you go to previous, there are some other pages are there. So explore that, then back, then explore then back, then explore then back, and everything is done. Then finally back to here. Finally back to the page here. Now here is the page. Just go there and start exploring. There are some pages. Just do explore that, back to explore that, back to, and then back to final one. This is exactly as we used to do in the internet. The same is DFS. That is the DFS. Exactly the DFS. So let's do here for V9. Okay. We have, sorry, for V6, we are going to do that. So we have, this is V6. Okay. So from V6, so we can go V7. Okay. So here is, I just went to V6, sorry, V7. Okay. Inside I went. So from V7, so any one of the direction, either I can go V5 or I can go V7. So I just choose a V7. So from V7, we have new vertex, no? We have from V7, we have new vertex. We cannot go because we have from here as here. We have some other pages. So from there, just explore that. So we have new page, new vertex, which is V3. V3 also has some new page. Just go in. Okay. From V2, have some new page, which is just go to V1. Okay. Now from V1, there is no new page. Then back to V2. Okay. Then back to V2. So let me write here V2. This is V1. This is V3. This is V7. And this is V6. Then back to V2. Then V2 have some pages, new pages also. Then let's go to the new page, which have V4. Okay. Which is V4. V4 have new page? No. There is no new page. Then back to V2. And then again V2 have new page? Yes. V2 have new page? V5. So see that V2 have new page V5. Okay. Then V5 is here. Okay. V5 have new page. V6 is there. V6 is there. This is already done. But V5 have some new page. What is page? V8. So let's go to V8. V8 have new page? Yes. V9 have. Previous one is there. There is V5 already is done, but V9 have. So just go to V9. Then V9 have no new page? No. Just go to back. V8. V8 we have new page? No. Just back to V5. V5 have new page? No. Just back to V2. V2 have new page? No. Back, and finally back. So see that this is DFS. Is this clear? Is this clear? DFS is how we will do exactly on surfing on internet.
Yes, sir.
Yes.
Exactly same as you are doing. Is there any page? Just go to that. Otherwise, no, just back. Is there any other page? Just go there. If there is no, just back. Back. Finally, on the Chrome page, which reaches. the home page. Exactly same. So see that the DFS and BFS, this is a DFS tree. I hope it is very much clear what is the how to find the DFS and BFS tree. Okay, this is one. Now next is the DAG. DAG. In one word, we can easily think. DAG is a directed acyclic graph. Even the DAG word itself gives the definition, which is directed acyclic graph. Okay. Directed acyclic graph. Acyclic means the graph which is directed. The graph which is directed, but which this will not contain any cycle. Like for example. So we needed, I'm just making the graph now. So at least it should be directed. So let me make it here the same graph I'm taking. Okay, but I will give the direction here. Okay, I'm just making the connection here and I have just given here the direction. So this is one, this is one, this is for this edge. Let's this one. Okay. This one, this one, this one. So see that if for the time being, if we assume this is the graph directed graph, okay, but this is not a DAG. This is not a DAG. Why it is? See that this is a cycle becoming, there is a cycle. This one, this one, this one, this one, and then this one. See, this is a cycle is there. So this is not a DAG. So I'm just removing. So I'm just explaining what is DAG. So I don't want DAG. Sorry, I don't want a directed acyclic graph. So I want a DAG, directed acyclic. So let me make it here this way.
Sir, one question from previous one. The BFS and DFS are the operation only on undirected graphs.
Even the directed also.
Okay,
Even for the directed, but according to the direction we will move only.
Okay.
So see that now this graph is a DAG. See that it have direction and but it don't have any cycle. See that this is going to a graph which is directed, but it don't have any cycle. So this is a DAG now. So once you have DAG, no, so there are two type of problem is there. Topological sorting and longest path. So so for the time being here, I'm not going to discuss that algorithm, no, how to in degree, out degree. For topological sorting, we needed in degree, out degree. But here is just while looking, we can try to find the longest path. Just looking whether even just looking the graph, we'll try to find the longest path. So what is going to be the longest path in this graph? How we will find? Longest path in the word longest means we want a path which is the longer one in the graph. There is no other. If you remove or even if there is an edge you are adding in the path, okay, then it will be means there you cannot add any edge in that. That is the only unique, not unique. That is only the going to be longest one. Okay. So how we will find that? So anyone, like any, you can choose any from any vertex and try to find that. You can choose any vertex, even V1, V2. So for the time being, I just chooses V1, or even for the time being. So if you choose from V1, so V1 actually there is no outgoing edge. So you can actually to find the longest path. That's why we need it. So to find the longest path, no, we will try to choose those vertex which have only outgoing degree, which have so that's where the in degree, out degree word will come. So let me write here the in degree and out degree. So in degree means here is we already told you in degree and out degree. So what is the in degree here? In degree is 0. So to find in the DAG, we are only talking about the out. There is no, we are not going to deal with the out degree. We just talk about the in degree. Okay. So in degree for V2 is what? In degree of V2 is 2. In degree of V3 is what? There is no in degree. Everyone is outgoing, so 0. In degree of V5 is 1. In degree of V4 is 1. In degree of V8 is 1. In degree of V9 is 1. V6 is 1. For V7 it is 2. For V7 it is 2. So to find the longest path, we are trying to choose those vertex which have in degrees 0. To find the longest path, we are trying to choose those vertex which have 0 in degree, 0 in degree. Choose that. So either you can choose V3 or V1. Okay. Now let's assume, let's choose or V3 even you can or V1. So let's choose V3. There's a look like easier. So let's choose V3. Okay. So from V3, just start moving. So if you go in this direction, it's finished now. It's just stopped here. So then we cannot, because if you here, then you cannot go this side. So then it is not a good way. So just choose this one, V1. Now choose V1. So if you chooses V1, okay, let me choose with a different color or even V1. So choose V1 and then start moving. I'm not going to discuss. I'm not telling you the algorithm. I just by the simply while looking you can tell, no. So algorithm, once I will do this, then I will discuss the algorithm. So choose V1 and then start moving. Just I reaches V2. Then from V2, if I go this one, it is finished now. So I'm not going to do that. So let's do the longest one. So I choose V2. Then from V2, I go here. I can go here. Okay. From V, I can go here. V1. And then if you go in this direction, okay, this is one. And then this is one. And now from here, we cannot go. And if you go with the same direction with here and then here. And any other way we can go so that we can find the longest path. There is no other possible way, no? Only this is the only possible. Because in degree, which have in degree 0, from there we will start. So I started from V3, I didn't find the longest path. Then I chooses V1 and then I have the more better than V3. Then what is the path here? Longest path is this one. V1, V2, so this is V5 and then V6 and then V7. So what is the path? That is 1, 2, 3, 4. The longest path is of the 4 edges, means 4. With the weight it is given, then easily can do. Otherwise, in the vertex form, it is you can choose like this. And if you go with this one, so this is one longest path. Okay, this is one longest path. Another longest path is 1, 2, 3, 4 also. So suppose if it is 3 only, so this is not going to be the longest path because both have the same longest 4 edges. 4 number of edges is covering is 4. So that is why it is going to be the longest path. With both have the same. Otherwise, if it is 5, no. So this is not going to be discussed. Only the 5 one we are going to discuss. But it don't have, so that's why this graph have 2 longest paths. V1, V2, V5, V8, and 9. Okay. This is one. While looking, you can do. Okay.
Choosing V3.
Choosing V3 will be okay. There is other way. So okay, let's do that. I think when I go with this way, okay. So any other way is also we are looking. So let me check with that. Okay. So just a minute. So this way. So if you go here and we start doing by this way, this, then this, then this, and then this, or this, then this. So is that 1, 2, 3, 4? Again, it is give the 4, no? Oh, so from V4 also you can get the longest path. Sorry, from V3 also give the longest path. So V3, V2, V5, V8, V9 also have longest path, or even this way also. So there are 4 ways we
Longest
can
path means from one vertex to other vertex, I must make sure the weight is the greatest, right?
Greatest
traverse
weight
to
is
the
greatest
greatest.
means, or covering the maximum number of edges. The length means the path have the maximum length. Length is kind of number of edges.
Sir.
Okay. And now the topological, what is the topological sorting is, we are trying to sort out the vertices such a way. Okay, we are trying to find sort out the vertices such a way that in an order, topological sorting means we are sorting the vertices such a way that it will follow a direction. Like suppose this is the one example is that doing the course. Doing the course means suppose here is, we write it again here. Vertex and suppose this is the edge we have. Okay, and the sorting means you are trying to sort out an order, or here is, you can see that this is the course like V1 course, V2 course, V3 course. So I think the same edge we want, no? Okay, so now let me erase here color thing.
Sir, when longest path question will be asked, it will be given the intervals, like give the longest path between U1 to U9 or U1 to U4, like that.
Sorry. Could you repeat, please?
Sir, when longest path question will come, it will ask the intervals, like give the longest path between U1 to U4 or U1 to U5, like that.
No. It is just directly ask what is going to be the longest path in the graph. Longest path in the graph. Yeah, if it is the asking in the between two vertices, then you can also give, because it is separately also given. But yeah, generally it is whatever I'm telling, that is the only going to be the way to find the longest path. Okay, one question, because we are doing on that only. So maybe the question will be asked on the same syllabus. Maybe not, only the sure thing is that so question will be asked in the same syllabus. So suppose you have the same DAG is there. So let me write here. The direction is this one, this one, this one, the direction. This is the DAG you have. Okay, this is the DAG you have. So these are the courses, because suppose you want to finish the course, then you have to finish some other courses, at least V1, V2. So what is going to be that order? How we will find that order? Okay, how we will finish that? So to do that, there is an algorithm. We have to do that. So here is, what is that? We have to note out the in degree first. So in degree is here 0, in degree here is 2, in degree here is 0, in degree here is 1, here is 1, 1, here is 2, here is 1, and here is 1. Now what is the process we will do? Well, try to remove that. So from here, which have in degree is 0, from there you will start sorting. Which have in degree is 0, you will start sorting. So either V1 or V3 you can choose. So let's assume I'm choosing V1. Okay. Once you chooses V1, just erase that vertex. Just erase that vertex here, V1. Once you erase this vertex, it will update it. It will be updated. That means if you just remove this V1, I am just unable to remove that. If you remove that, it will be, so let me make it here. So this is V1, this is V2, this is V3, V7, V6. This is the direction. V4, V9.
So now what are we trying to find?
So we are trying to find an order. We are trying to sort out the vertices, all vertices. Okay, we are trying to sort out the vertices. Like here is the problem in the real life problem is these are the courses you have, and this is the order. Like you want to finish the course V8, then you have to first finish the V1, or you have to first finish V2, or you have to first finish V5. Okay, then you are able to finish V8 or V9. Sorry, this course V8. Sorry, V6 is there. This is an so in which order we want to proceed. Okay, we have to proceed. So here is in degrees written, no? So here is in degrees written. So choose the in degree which have in degrees 0. So the problem is every DAG have at least one vertex which have in degrees 0. Okay, every vertex or sorry every graph have a vertex, at least one vertex which have in degrees 0. Like here it have two in degree. Sorry, two vertices which have in degrees 0. So you can choose any one of them, either V1 or V3. So if you choose V1, okay, I'm just start sorting out. I choose V1, okay. If I choose V1, okay, so just remove that. Once you remove that, then in degree of V2 will become what? Previously it was 2, but now it is 1. Okay, now it is become 1. Now which have in degree 0? V3 have, right? The same graph it is. I made it for the removing one. So now V3 have, so choose V3 here because V3 have in degree 0. Okay, V3 have, okay, let me do it here. So V3 have in degree 0. So to just remove that. So I just remove this one. Okay, I just remove this one. So let's do an update here of the in degree. So what will be the update? So update in the V2 degree will be 0. And update in the V7 degree will be from 2 it will become 1. Okay. Now you have, now this is also a DAG which have in degree 0. So now remove V2. So if you remove V2, okay, if you remove V2, see that what are the V4. V4 in degree is 0. V5 in degree will be is what? 1 over there. So now it has 0. V5 becomes 0. And that's all. So now either you can choose any one of them. So let's finish with the V4 also. Then we can do 5. Because if you choose V4, then there is no effect on them. Then V5, choose V5. V5 in degree is 0. So let's remove that V5. So if you remove V5, then there is update will happen. Now update is what? This in degree of V6 become in degree is 0. Previously it was 1. Before to remove V5, it was 1. Now update will be then for V6 in degree will become 0. And also in degree for V8 will be what? Also 0. So any one of them you can choose. Either V7 or V9. So if you choose V8, and if you choose V8 and then remove that, then in degree of become V9 is 0. So in degree of become is 9, 0. Now you can choose again V9 or V8, V6, sorry V6. So any one of you can choose. You can choose V9 and then V9, and then if you remove that, there is no effect. Then you can choose here V6, and then if you remove that, then V7 you can choose. V6 and then V7. Any order. There is more possible
V9
orders.
also we choose.
Yeah, V9 also already chooses here. Even in whatever other, there are swapping thing also possible. Means swapping means some have already V6 have V0, right? So it could be previous, it could be follow V4 some other vertex. But yeah, it's depend on how you are choosing. So there are other topological sorting is also possible. Okay. So longest path and topological sorting is done. Okay. Now let's move on to Dijkstra algorithm. Dijkstra algorithm is, because now the next is there's two algorithm will remain, Prim-Cell Kruskal, and I think will not take much time. As the same graph, on the same graph I'm doing everything. Okay. So next topic is the finding the single source shortest path. The problem will be asked, what is going to be the shortest path between two vertices? So Dijkstra is there is two algorithm. So there is a weighted graph word is there. So this graph is a undirected and also unweighted graph. There is no weight. So let's give the weight here. Okay. Okay, so let me give the weight here. Weight for each. Weight means here means giving to the some value to the edges. Means here you can think that these are the cities and this is the cost price of reaching to the cities V1 to V2, C2 V2 to V3, or C2 V2 V9. So these are means how much amount or cost price means here is how much rupees or the driving or even the flight charge or anything you can think. That is the weight related to that. Okay. There is a transitive closure thing that we just jump to the. So also there is a transitive.
People what they can refer to the lecture, sir, because it was recorded once, I think.
So for the time being, if you are not going to discuss, that means that is not important topic. So whatever the topic I just wrote for the time being, you can assume that is only the topic will come to the end.
Okay.
Thank you, so you can assume that. Okay. So those topic is enough to study, or getting to the problem related to that you can study. So like Dijkstra or minimum vertex over DFS, VFS is one important. And also,
so can you just explain independent set and perfect matching at the end, sir?
So I already discussed that. Please watch because that is already done.
Okay.
I've just see that this is I have just explained. Perfect matching is here. Independent set is here.
Okay,
and it took more time.
Yes.
Okay, so let's do the Dijkstra algorithm. So there is some important things that is there will be a weight. So weight is cost, flight charge. You can suppose these are the flight, and from one city to reach another city, the flight charge is the some $100, $100, or in rupees, 5,000 rupees or 6,000 rupees or 8,000, 10,000, 20,000. So let me give the weight here. So let's suppose this is the weight. This is 2, 3. This is 1 you have. So in the Dijkstra is work to find the shortest path. Means let me finish that. So this is going to be 8, or this is 7, or this is 3 you can give, or this is 4. This is 1 you can give. This is 2 you can, or here is 3. Let's do 3. Okay. So suppose this is the graph you have. Okay, so the weight is also I have just wrote here. Okay, this is the weight related to the edge, and okay, we want to find the shortest path between this vertex or V3 to V9. Shortest path in terms of weight. How we can proceed to reach from V3 to 9 so that the weight will be minimum. So the Dijkstra algorithm is given algorithm. Dijkstra algorithm is given process or algorithm so that you can find the shortest, or you can find the path which give the minimum weight. So like suppose for the time being, okay, if you go by this route, okay, let me change the color. Okay, if you go from here, from I want to find the shortest path from V2 to V9. Okay, this is the path I want. Okay, from V2 to V9 I want to go. Okay, so if you choose by this way, if you go by this way, then this is the 3,000 or charge you can say. So if you then from this way if you go, then this is 8, and then this, and then this. So what is the weight? 3, 8, 2, 2, 3. So this 11, 13, and 16. One route is 16 give. Another route is if you go with the this route, this is one, this is one, this is one,
So
and
13.
then this gives 13. Any other route is there? Possible route?
No,
No.
sir.
There is
Not
no
yet.
other, there is no other way to go. So see that now the shortest path is to go to V3 to V9 is going to be this route. Even you can see that number of edges covering the number of edges like 1, 2, 3, 4. This one is chooses 4, but this 1, 2, 3, 4, 5. This one is chooses 5. But it doesn't matter. We want in terms of weight.
So the
Means what is
shortest
the
path is
weight?
based on weights only, weights. So irrespective of the number of edges
In
traversed.
terms of weight is only. So in terms of weight, we are going to we are talking about what is the weight is going to be with this one. Okay. So this route is the one. So the extra algorithm is actually now we can raise this one, or so this is one direct way you can think. So this is one direct way. So Dijkstra algorithm is says it is on the fire. Every time if you want to solve some problem, just think on the fire thing. If a graph is given and said that using the Dijkstra algorithm or find the shortest path, which way it will go, or which way with path will choose to reach some particular city. Okay. So always you can think with the fire one, that is a good one. That is a give a feeling to that, okay, the fire is going on in 3 minutes, 5 minutes. So like this you can think. So like if you start from here, you want to find the shortest from V3 to 9. So suppose this is the burning point, and if you go this way, so this takes 3 minutes to here. In between time, within 1 minute, this will be done.
Your cursor is not visible.
For all of you, is that? Or my cursor is visible, right? No? Yes? No?
Sir, actually, we want to
Yes.
see how you move your hand on the screen while you're comparing or showing something, no, sir?
So that's why I'm saying
As
my cursor is not visible to all of you.
Yes, sir. Your cursor weren't visible for all this time.
All this time, like in the previous one also. This one also.
Yes, sir.
No, in starting it were visible, no?
So no, sir, the coloring is visible, but the movement of your cursor is not moving.
Yes, sir. From the beginning itself, your cursor was moving, wasn't moving, sir. Like it was like there at one point only.
whatever you are writing, sir, it is very much
The
visible.
writing and the coloring is visible, but for example, you're showing from here to there, like we don't know from what you're trying to explain.
While you explain, no, sir, while you're comparing, showing, etc., that we cannot see that thing. As sir, we have a mouse arrow on the screen, no, sir. That is, we want to see that arrow like something or pen like something.
Am I audible right now?
Audible, sir.
Yes,
Yes, sir. Just got disconnected. My screen is visible, right?
Yes. So hereafter we'll explain, you just color it and explain. So it will be
Yeah, while coloring, I will try to do that. Using the color. So my screen is visible, right?
Yes, sir.
Okay. So suppose this is the, from here we want to find from V3 to V9, we will try to do. So, okay. So by this way if you try to move, so the weight is here already given 1, okay, and here is previously turbo. So here is weight is, if you will go with this way, it is weight is 1. So burning, the same burning time, you can think this weight is 3. So if you, from here, if you move in this direction, or fire is started moving in this direction, so once it will reaches to 2, vertex 2, within 1 minute, before reaching to vertex 2, within 1 minute, this vertex or this vertex will be fired within 1 minute. Maybe once the fire will move along here till here, if it reaches, before that it will be fired V7. Okay. And then after 4 minutes, it fired this one, but within 3 minutes, so total is 5 minutes. Total is 5 minutes to reach here. Vertex 6, it took 5 minutes, but within 3 minutes, it's fired here. Now it will start moving in this direction, and in this direction. In this 3 direction, it will start moving. So, but it will take, in this direction, it will take 8 minutes. Okay, but here it will take 8 minutes. So total it will take to till reach here, it will take 11 minutes, but by this way it reaches to within
8 minutes.
8 minutes. Within so after 8 minutes it will reaches. So here it is a long path, and it took 11 minutes to reach by this way, but before 11 minutes it will fire this one to 8 minutes. This vertex is fire within 8 minutes, after 8 minutes. Now both sim will start moving. So after 10 minutes, so after 8 minutes, it will start moving this way, and this way there is only one way. So this is give the minimum one. Otherwise, it will, by this way it will come. So this will be 2. It will take by 8, 11, then 2, then 3, 16. So this is the Dijkstra algorithm, even the same way. So this is the Dijkstra algorithm, means it chooses the minimum weight path. It will start moving minimum weight path, then reaches to. Okay.
yes.
Now let me so I'm not going to, so Dijkstra is the for the only the positive weightage, it will work only the positive weightage. For the negative weightage, we are going, there is a Bellman-Ford algorithm and Freud-Wursel algorithm. So that is not going to come also, and also you can skip that. That will not come in the question and in term, and also it will take more time. So that's why you can skip those algorithm. Okay. So here is suppose, now let's move to
Sir,
MCST.
both the algorithms. Sir, both the algorithms.
Yeah, both algorithm. So MCST is minimum cost spanning tree. So first thing, what is a spanning tree? A spanning tree is a tree. It is a subgraph of a previous graph, which contain all vertices, and is a tree. Means it is a subgraph. So it is a subgraph, or it is a subgraph, and it is a tree also. But in that tree, or in that graph, or in this spanning tree, you can there you will see that there are some lesser edges in compare of this one. But yeah, all vertices will be there. All 8 vertices or 9 vertices. This tree also, a spanning tree also have all 9 vertices, but number of edges should be lesser than that. That means it is a tree. Okay, that is a tree. And you can say that is the name of the spanning tree, means it will contain all vertices and even some edges. But if you add some whatever according to the start adding the edges, it will exactly you can find the same vertex, sorry, same graph. So that's the span. That means a span, it can found that exact, but you can find that exact graph using the previous one, spanning tree. So the spanning tree is it will span the graph. You can find the graph using the spanning tree. So like for the suppose, for example, I suppose you have a graph, this one. Okay, suppose this is the graph you have. The spanning tree for this graph is what? This one. This is a spanning tree. So for a graph, there are more possibility to find the different spanning tree. So this is a spanning tree. Okay. There is another spanning tree could be possible. This one, this, then this, then this, and then this. This is a spanning tree. This is another spanning tree. See that all vertices is actually there. Yeah, some edges is not there. So this is the mean of spanning tree. This is the meaning
For
of.
which graph are you drawing the spanning tree?
For this graph.
Okay, sir.
Okay. So this is the spanning tree for this graph.
Not cyclic.
So it is not cycling. No, tree is what is there. That means there is no cycle. There should be no cycle.
In all the vertices, but can leave out some edges.
So here is minimum cost spanning tree, means we are trying to find that spanning tree. So here is spanning tree. So see that this is a spanning tree and this one is a spanning tree. This one is spanning tree. But we are trying to find the spanning tree, such spanning tree which have, once you count, suppose here is weight is given, no? So and also if you found the count weight is for this one, no? For this one, if you count the weight for this one, the total count the weight, which is going to be minimum, you said that you will say that is the minimum cost spanning tree. Suppose for this graph, whole vertex have some, so weight is given for the whole graph, okay? But once you find the weight of this graph, okay, total weight, suppose that is 19, and for the weight for this graph, the weight is 18, then your minimum cost spanning tree is going to be this one, because this is the minimum weight. That's the meaning of minimum cost spanning tree. So how we will find the minimum cost spanning tree for this graph?
The minimum cost spanning tree means you have to add the vertex, edges weight. So means you have minimum, means there are two algorithms to find the minimum cost spanning tree. I said you the minimum cost spanning tree means what? What's the meaning of minimum cost spanning tree? Now the problem is how we will exactly find the minimum cost spanning tree. So there are two algorithms. One is Prim's algorithm and Kruskal algorithm. Okay, but so what is the difference between them is, suppose using the Prim's algorithm, you found this minimum cost spanning tree, and using the Kruskal algorithm, you found this spanning tree. Okay, for the time being, I am saying, forget about the weight, forget about this weight. By Prim's algorithm, you found this spanning tree, and by Kruskal, you found this spanning tree. But if you count the weight for both, it will be the same. It will be for the 18, it will be 18 for the same. So Prim's and Kruskal both give the same weight of the spanning tree. Yeah, there is a difference. There could be difference. There could be possibility that their spanning tree may be different, but their weight, exactly the whole, both weight will be the same. See that structure. If they see the structure, this graph and this graph, both have different. But see the weight. Finally, you counted the weight, both have the same weight. Okay. So Kruskal and Prim's give the same weight, yeah, but there is a possibility that their spanning tree may differ. So because the reason is why it is differ, the reason is their algorithm is different. So what is the algorithm? So first let's see that Prim's algorithm. So Prim's algorithm is what? Prim's algorithm says why I am telling by looking here we can tell. So Prim's algorithm is, let me change the color first. Green. So Prim's algorithm says choose the minimum weight edge. Okay, this one. Once he chooses this one, I start expanding. I am explaining Prim's algorithm. Okay, so first be sure and see very carefully Prim's algorithm I am displaying. So choose the minimum weight. Either you can choose this one, or you can choose this one, or and which have the one, there is no one. Okay, choose the minimum weight edge. So let's choose this one for the time being. Let's choose this one. Choose this weight. Now start expanding here. So this way you can, from this vertex you cannot expand. Okay, there is no edge. This, from this vertex we can expand. So which have the minimum weight? That side, that edge you can include. You cannot include this edge because it have 3 edges. 3, but you can include this edge because it have 2. So include this in your tree. You are actually growing a tree. Okay, you are growing a tree, so you are added an edge here. Now from this vertices try to expand. Okay, try to expand your road. So if you start now moving, so again you have v2, because from v1 you cannot expand, from v2 we can expand. So if you move this one, we have 2 ways, this one and this one. So in between we have to choose. Then I will choose the minimum one, this one. Okay, this one I will choose. Now from this one, which is going to be minimum one? Okay, in between in this vertices we have v1, v4, v5. In this, which we give the minimum connected edge is the one is this one and one is this one. So I will again choose the minimum one. So choose the
V3 to
minimum
V7.
one. This one. And then again, whatever the chooses vertices, this one, this one, this one, this one, try to grow and choose the minimum weightage. Which have the minimum weightage? V7 have. So grow by this way. Then again, similarly, try to do that. This one have. Then again, this one have. And again, this one have. By the same way, I'm not each time I'm to repeat the word. So this is going to be your spanning tree. See that? This is your spanning tree. So this is your this, this. Now the weight is 2, 3, 1, 4, 3, 2, 3. Okay. The weight is 2 plus 3 plus 1 plus 4 plus 3 plus 2 plus 3. So this is 5, 6, 10, 13, 15, 16. So this is the Prim's algorithm we have. Okay.
So what about
now
V4
Then you
to V2?
forgot V4,
V4 to
V2.
V2.
V4 to V2. V4, where is V4? V4 to V2. Where is V4 to V2? Here is V4. Where is an edge? There is no edge, no?
So we
Am I audible?
started from these.
Yes, sir. That is there, sir. Started from there only.
I started from
V4.
Oh, okay. Oh, sorry. I forgot V4 and V2. Oh, sorry. This one. Oh, sorry. This one. V4 and V1. Sorry, V2. This one. This is one. And then one added one. Which is 17. Yeah, yes. This is the tree. This is our tree. Again.
So,
now
sir, so the Prim's algorithm will first choose the shortest weight vertex, and from there it will search for the next shortest
connected
vertex,
with
which
that.
is
Whatever the
connected. Yeah,
chooses
sir.
vertices you have, using those
Yes,
only
sir.
you will try to grow. This is a growing one. So see that this is a growing one. It is try to you have put a tree, small tree, or a small edge, or a small vertex edge you give, and from there you start growing by leaf, or by leaf you can think with the vertices. So from vertices you will start growing. which have the minimum age, just start from there. Now see that the difference between Kruskal. So what is the difference? Let me write here. Kruskal is it doesn't show the grow. It will not tell you the grow. It will tell you choose the minimum. Which have the minimum? This one. Which have the minimum? This one. Okay. Choose the minimum one. This one. Separately, it is not choosing. It will not growing. It is actually choosing one. So Kruskal is actually choosing. Okay. Kruskal or C or K something. Kruskal is choosing one. Okay, choosing. See that how it is chooses? Choose the minimum one. This age. Now choose the minimum one. This age. Now choose the minimum. Which have minimum? This one. Now choose the minimum one. This one. Then choose minimum one. Which have minimum? 3 it have. This one. Now choose the minimum one. 3. This one. Now choose the minimum one. This one. Now choose the minimum one. This one. Okay. Now, and you will choose such a way that it will not form a cycle. It will try to now not form a line. Try to form a. It will not try to form a cycle, and your algorithm will stop once it chooses all vertices. Means here it is done. It is almost done to choosing the vertices. Okay. You will try to choose such a way. No. No. Sorry. It will stop not vertices with the vertices. It will start with the such way that you will not. It will not form a cycle. Try to choose a such a way. Like here is, if you choose now, the next is if you try to choose the age, so it will choose. You cannot choose one. The reason is now it will form a cycle. So let me erase it again and let me again the word. Let me write it again with a different color. Let me take the blue one. So what is that? Choosing one. You will choose among this which have the weight minimum, this one and this one. So first choose this one. Okay. Now choose the minimum one, which have the minimum. Once you chooses, I chooses here. Now choose the minimum one. After choosing, just
V3, V6. Sir. Sir.
Hello, am I audible?
Yes, sir.
Yes, sir.
Disconnected. I don't know. Night time it is happening. Okay. My screen is visual, right?
Yes, sir.
My voice is
Yes,
clear
visible.
and my screen is visible.
Yes, sir.
Okay. Okay. So this is the see that this is the differences that choosing one and you have to choose that. So slowly it will connect it. It will connect. Okay. You will start choosing ones. It will slowly connect. Now choose the minimum one. So you will choose the minimum one. This one. This one. You'll choose the minimum one. This one. Now choose the minimum one among that. So you can choose this one. Choose the minimum one. This one. Slowly, it will slowly will connect it. Okay. It will slowly will connect. This one, this one, this one. So slowly, if you see that, it will connect and finally count the weight. Okay. This is the Kruskal algorithm. But Prim's is what? Growing one. Prim's is growing. Okay. This is the difference between choosing and growing in Prim's and Kruskal. Okay. Okay.
Sir, growing means?
Growing means what? Here is once you chooses the minimum and from minimum you will start grow, which have the minimum one, this one. So from here now start grow, this one. Okay. And then which one have minimum? This one. Grow. This side, like this it is grow. But Kruskal is choosing one, like choose the minimum one. You chooses this edge, now choose the minimum one. Choose this edge, now choose the minimum one. Choose this one.
In not one direction anywhere. We choose
Anywhere there is no direction. Yeah, maybe some have direction, some have no direction. But this is talking about the undirected graph. Okay. So these are the topics in the graph theory. I hope
Excuse me, sir.
Prims and Kruskal also done.
Please explain by example one. Take question.
So that's the one thing. Now I'm going to discuss the doubts. So in the doubts, surely it will come some Prims and Kruskal.
So can you solve the mock test for last question? Mock test is a last question.
So mock test last problem.
So actually question 11.10, question 1, 2, and 3.
Okay. So this one, this coloring, this one.
No, sir.
This is the last one.
Yes, sir. Please explain this.
So it's different for me. It's question number 17 in my piece, sir.
So that's why it is a kind of randomized, no? Maybe some people get different, some people will get different.
Okay, so can you solve this and I'll show you the question after you solve this, sir.
So this problem is talking about the vertex coloring. What is going to be the minimum number of colors could be possible? So this is the graph we have. So let's start coloring it. So I just chooses the color this, and I color this vertex with this color. Okay. So I cannot color this with the same color, but I can color this one. Okay, once I color this one, I cannot color this one. I cannot color this one. Okay. And also with the same, I cannot color with the same here also. This one. So, but I can color this one because there is no connecting edge. So I can color this one. Okay. Now I cannot color this one. So these all are the different color. See that whatever I colored, I have colored the vertices. Those are actually not connected.
Sir, I can't understand. Please repeat.
Okay. Okay. Start coloring any one of them. Suppose I colored this vertex with this color. Okay. So there is an edge for this vertex, and this vertex.
Yes, sir.
So I cannot color this vertices with the same color because there is a direct edge. But
Yes.
if you can color this vertex with the same color, because there is no direct edge with this, right? There is no direct edge. So you can color this one. And now repeat it, start repeating the same algorithm. There is an edge here. You cannot color with the same color. So you cannot color with this color. Already this is done. But this you can color, because there is no direct edge with this one or this one. Then again you cannot color with the same color this one, because this is a direct edge. Okay. Now the one color is done. Now choose the next color. Okay. Choose the next color. Remaining from, start again from the remaining one. If you color with this thing, okay, this vertex, then you cannot color this one with the same color. But yes, we can color this vertex, because there is no direct edge with this one and this one. There is no one. So you can color this one. But once you color this one, you cannot color this with the same color. The reason is there is a direct edge. So we are done. Now the color is, we needed next color. Otherwise we cannot do, now we cannot do the different. We cannot do with the same color. So choose the next color. Now I start whatever the color thing is done. Sorry.
4 colors will be required minimum.
So now choose the, okay, so choose this color, this vertex with this color. Now if I choose this vertex, this, we cannot color with the green, okay, but we can color this vertex, because there is no direct edge. So I can color this one. Once you color this one, still one vertex is remain, so you need to different color. So
Yes,
by
sir,
this
got
color, by this color you can color this vertex. So how many colors are there? 1, 2, 3, and 4. 4 colors are required to color this graph. Okay, let's do for this one topological sorting. Okay, this problem we can do quickly. Many people have doubt, so let's do the same. We want to find the topological sorting for this one. Okay.
Second is this are actually question 11.10, question 1 to 2 and 3.
Okay, okay. Let me finish this one. So we want a topological sorting. So again, first write down the in degrees. So here in degrees 0. Here is in degrees 3. Here is in degrees what? 1. Here is in degrees 3. Here is in degrees 2. Here is in degrees 1. Here is in degrees 3. Here is in degree. What is in degree here?
2.
2. So I just note down all in degrees and I start doing the algorithm. Okay. So which have in degree is 0, just remove that. Okay. So once I remove this one, okay. Here is removing is right one. Once I okay. Right one. Suppose you can think that this is I just colored. Okay. So I just remove this one, then in degree will be updated. Okay, I just updated. So what is the in degree will be update? In the in degree, it will update in degree is going to be here 2 now. Updated in degree will be 2 here. Updated in degree will be here 2. Updated in degree will be here 0. Okay. So let me with that different color here. There is, I think red will be good. So here is, I just removed this one. Okay. This edges I have just removed. Okay. this E have removed. Okay, I just removed the E. So I just removed the E here. Okay, then I have updated. So now in degrees, what here is in degrees F have. So list out that. Okay, so let me list out that. Here is E. Now in degree for F we have. So F is there. Now once you remove F here, so what is that? Once you remove, this edge will be removed, this edge will be removed, and this edge will be removed. So update the in degrees of according to that. So once you update the in degrees, so here is previously 2, it will become what? 1. Previously it was 1, so it will become 0. Previously it was 3, so now it will become 2. Okay. Okay. Now which have in decrease 0? C. Now again, if you remove C here, so if you remove C here, so update will be here, 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 and here. This will be update. So what are the updates in degrees have? Previously it were 1. Now it will become 0. It were 2. It will become 1. It will previously it were 2 here, so it will become 1. So it is 3. Now it will become 1. Now C, I just removed C. No, from C have I removed. So now C is, once you remove C, which have 0, now B have. So once you remove B, again this will update it. This edges, this edge, and this edge will be, sorry, this one, not this one. This edge and this will be update. So once you remove B, this will become what? The in degree of this one will become 0. This will become from 2. This will become 1. Right? Because these two edges, this one edge and this one edge is removed now. So in degrees become 1. Here is this in degree is 0. Why? Because this one is removed and this one is removed. And similarly, the same way, now there is nothing. So now you can, G is there. Once you remove G, then A will be become, this one will become, and this will become 0, 0. So you can choose A, then H, and then D. So this is going to be topological sorting. Another, and the same, I just quickly wrote. Now I'm just leaving for you to do that. Is that clear what I am doing here?
Yes.
No?
Sir. Yes.
Okay.
Yes, sir.
So this is one topological sorting. Okay. Any other graph problem? Let me see it here. This is BFS tree of G shown below. Choose the option which may represent the original graph. Okay. Which may represent the original graph. So it is asking for may, means there is a possibility that to choose the BFS tree, this is a BFS tree is given. So this is the same label is given. No? So this means that, okay, let me take the here. We can easily make it here. So how we can do? This is a tree is given. Okay. This tree is given. So here is in BFS, I said no, it is a label wise. If it is 0 level, then connected edges will be of the same level. So this is of level 1, this is level 1, this is level 1. Okay. This is of the same level. That means there should be a direct edge. And then if it is the same level, okay, if it is the same level, then this is going to be level 2, level 2, this is going to be level 2, this is going to be level 2. So there is a possibility that there should be an level 2 of the same level have the edges. There could be possibility that of the same level have the edges. So this one have, so this one have, so I have to check it here. Okay. Of the same level or of the same level have or one extra level have the edge, and so this is the same level. So there could be an edge, there could be an edge, there could be an edge, this could be an edge. So like this, the edges could be possible. Okay. I think this is in the, this problem is I think in the solve with us. So while looking the graph, which could be possible by here, while looking the, we can see it here. So see that on the same level have edge. So this could be one. All four options have the same thing. Okay, so this could be not. The third or fourth option cannot be. In between three, we have to choose. On the same level have edges. Is there anyone which have the same level have no edge? So these three have. Now in the level one have also edge. So there should be an edge. This one, this one. So this have all have. Okay, this one have. This says this is one level one. This is So this is one level have also edges. With
Sir,
respect
can
to
you
this
please
is.
scroll to the question, sir? Because I am having a different question, I think.
No, I'm just explaining this problem with the BFS tree.
Okay,
so I don't
sir.
know all of you are getting or not. What I'm saying here, is that clear? So
Yes, sir.
You
there
have
is
to go
simple
by
one.
level by level, right? Please.
This the meaning is if it is the same level or one level difference is one, there is an edge. Okay. If it is the same level or there is one level difference, the difference level is one, then there is a possibility an edge. If there is a level difference is more than that, then there is no edge. So by this way, you can do this problem easily.
Sir, and level difference will be if 0 like 1 and 5, how they will be connected, like 1, 5 and 3, 6.
1, 5 and 3, 6, 3, 6. Yeah, because the level, if you count the level here, no? If you count the level now, level of 1 and 5 is what? Level of 1 is, this is 1. Level of 2 is 2. Sorry, level of 5 is 2. Because they are growth from here. This is growth from here. So this is going to be level 2. So there is a possibility, same level and edge, or level difference is 1, then edge. If level difference is 2, then no edge. But see that here is level difference is what? 1. Then there is a possibility that there is an edge going to be. Okay. Is this clear?
Yes, sir. Yes, sir. Got it, sir.
So by this way, you can find. Now you can, all of you can get that what is the possible graph would be. Okay, this is the vertex for this problem. So this is the graph problem. So let's do it here. All the graph problem, we'll try to finish it here. Okay, before that there is no graph. So there are only 1-2 problems are there on the graph. Okay, so let me finish.
Can you please do week 11 assignment question number 3? It's a graph.
So I've been waiting, for the mocked last question, sir.
Last question is this one, no? Now there is no.
Sir, I have a different question, so I ordered to produce.
Okay.
So can I share the screen, sir, if you want me to?
So just a minute. Let me finish this one. So here is, it is asking find the root vertex of G. This is a directed graph. If there is a direct path from U to every vertex in the graph, a vertex U is called the root vertex of a directed graph. If there is a direct path from U to every other vertex in the graph, below is a directed graph G with the vertex 0, 1. Find the root vertex. What is going to be the root vertex here? Here is the definition is written. A vertex U is the root vertex of a directed graph if there is a direct path from U to every other vertex. Sorry, directed path. Sorry, directed path. So which
2 is the root vertex.
So from 2 we can, or if you choose 1 by 1, you have to check. If you choose 1, then from 1 you cannot reach to all other. From 0 you cannot reach to all other. Only the 2 is there from 2 where you can reach to all other. By if you choose, see that from 2 you can reach to 0, from 2 you can reach to 4, from 2 you can reach to 5, from 4 and then 5. From 2 you can reach 1, from you can reach to 3 by this way, from 2, 1 and then 3. So see that this is 2 is going to be the root, because from 2 you can reach to all other vertices.
Sir, can we also tell that if the vertex has 0 in degree, then it can be the root vertex?
No, not necessary. Not necessary. This have the 0, but they're not necessary.
Okay, sir. Got it.
Okay, this is for minimum cost spanning tree. So let's do it for this
Rashi
one.
sir, tomorrow there's a mock test discussion, sir. So today can we have the doubts from the other activity?
So let me finish this. Somebody have the Kruskal or let me finish this one for the minimum
sir.
cost spanning tree. Okay, then we can this problem. Let's finish this one because we have some. So this is one better example to discuss with the Prims and Kruskal. We have done the algorithm now itself. So here is, let me.
So we cover Kruskal in this question.
Sorry.
Sir, Kruskal algo used in this question.
So in this problem only asked for the minimum cost spanning tree. Okay, here is minimum cost spanning tree is asked. There is in this problem there is it is not asked that by the Kruskal or by the Prim's algorithm try to find the minimum. In this problem it's just asking the find the weight of the minimum cost spanning tree. So we'll see that by the Prim's and by the Kruskal, and we'll see that how it will work. So Prim says choose the minimum one. So I'm going with the Prims first. Okay, Prims first. So choose the minimum weight H. So I chooses this one. I chooses this H. Now start growing. Start growing. So which have the minimum from these two, in between these two vertices?
C1, C2.
This one. So any one of them. So if you go with this one, and again start growing with the among these three vertices which have the minimum, this one, right? Okay. Now among these four which have the minimum connected with the connected edge,
C2 to C3.
this one, this one, this one. So this one, yeah, either this one or this one. So I choose just this one. Now minimum one is again going to be this one. So this we cannot
do. A cycle.
So this we cannot do now because this is a cycle.
So you should go for C2 and C3 first, right?
Also, so this is going to be minimum one. This one. So this one is going to be. Now choose the minimum one. Among this, whatever we have done with the vertices.
C0 to C4.
C0 to C4.
C0 to C4. Yes, this is the minimum one. So this is going to be minimum one. And also we are done with the all vertices. Now we are going to stop here.
So what about C3 to C4?
C3 to?
C3 to C4 or C?
C3 to C4 is not because
okay,
this is 7. This
all
is
the vertices are completed, so we need not go for.
So this we are and also we are done with the all vertices. So now you can count the weight here. Okay. Now you can count the weight. Now let's do for the Kruskal again. So for the Kruskal says to do the minimum one. Okay, what will happen? So do with the minimum one. So minimum one is choose this one. Now choose minimum one. This one. Now choose minimum one.
C1 to C2.
This one. Now choose minimum one.
C1 to C6.
Now choose minimum one. Is going to be
C6 to C5. C6 to
C5.
This one. Now minimum one is
C0 to C4.
This is only one. So this is our
same.
The same way actually we are getting. Okay, this is the Kruskal. Kruskal is choosing one. Prims is growing one. Okay. Now count the weight. Okay, somebody have some other doubt? Please let me know what is. Now I am done with the mock. Mock in the graph related that we are.
Sir, can I share my question, sir?
Yes. So please raise your hand one by one. That would be like Sudhir is the first one. Yes, Sudhir.
So I have been waiting since so long.
Yes, sir, I have doubt in graded.
Graded.
So I also have in graded.
So if you have graded, can we go with the solution, because I have just given the solution also.
Okay,
Particularly have, then that is like like if you are not getting the concept, then we can discuss. If you have doubt with the number or answer, then I have uploaded the solution.
Sir, in concept only.
Okay, what is the concept? So in that problem, okay.
This is question number 2, sir. Question number 2.
Okay.
So have you done types of edges?
Type of edges.
Sir, when will you answer my question, sir, about the mocks? Sir, I have been waiting for half an hour, sir.
Okay,
I was more than
I
that, sir.
use.
Sure.
Okay. I don't know what way happening with today. So somebody have doubt. What is that? Also,
So I have
what is your
doubt in mock
mock doubt?
test, sir. Yes, a mock test. Last question, sir. It's about
So what is that question?
Sir, it's employees of the IITM
What is
online
that
degree.
problem?
Employees of the IITM online degree program are assigned to visit the exam centers in Chennai. Vidya has been asked to arrange cab for these employees to drop them at centers. She has created a graph and asked Sanya to arrange the minimum number of cabs, but has forgotten to tell Sanya what the nodes and the edges represent. Sanya has assumed the following cases and found the answers accordingly, and there are 2 cases given, sir. So shall I share my screen, sir? It's a pretty long
Yeah, you
question.
have to share, then I will get it. So yeah,
Alright,
you can share.
We do graded before sharing this.
Sorry.
So can we
Let
do
me finish,
graded?
because it's a longer time. He just from the starting, he just saying to. So where is your screen? I don't know how I can get. You have started your. What's your good name?
Nicer, who is asking for the mock, sir.
Okay, okay. What is your name?
My name is Sujal, sir.
Suraj.
Sujal, sir. SUJAL.
So sorry, Sujal. So
Yes.
where is your screen? I am not. How I can.
So I cannot share while you're sharing the screen, sir.
Okay. Okay. So yeah, host have. Only host can. I can only share.
No, sir. You're already sharing the screen, so I cannot share while you're sharing. So you have to stop sharing.
Okay, I have just stopped now.
So this one, sir.
Okay, employee. Sir. Okay, employee of the item degree program assistant. Okay. This implies to be She has created a graph and asked Krishna to arrange the minimum number of caps, but has forget to tell Sanaya what the nodes and the edges represent. Sanaya has assumed the following case and found the answer accordingly. So can you go to below? First case is nodes represent the location of employees and edges represent the roads connecting to this location. Okay. Apply from any one of the location minimum number. So Sanaya needs to arrange the minimum number of caps under the assumption of each employee. Okay. Nodes represent the employee. If two employees are share an age, they are assigned different center. Now Sanaya need to arrange the minimum number of caps such that no two employees assigned for the different center should come. So what are the options? Case 1 would be the solve by finding the maximum number of element in independent set. So here is the minimum in both cases the minimum number is there. So maximum number is not work. Minimum number of caps is required according to the case 1. According to the minimum number of caps is required 3. So here is cap is for which is for cap problem. Cap problem is, so what is Sanaya needs to arrange a minimum number of caps. Here is the Sanaya needs to minimum number of caps. So here is minimum number of cap means here edges represent the cap. No. So and edges represent the roads connecting, and each can pick up the employee. Here is so by the road. So minimum number of vertices. So cap is actually can be done with a number of minimum number of. So cover here is a covering. No covering problem is that.
Sir, can I stop my screen share so you can do it in like the whiteboard and explain more clearly? Sir,
yeah, so you can do with this one with the minimum covering problem. Using covering problem, you can do that.
Sir, can you please do it, sir? I think that would make it more clear.
So here is just show me the graph. So covering is you can do that like this. If you choose this vertex, then it's covered that these three. This one I can tell you. Okay, and then like covering, just now we discussed to cover the vertices, no? So covering, if you choose one vertex, then it's cover the edges.
Yes, sir. So like if I use this, then this and this will not be covered. This and this will also be covered, right, sir? And this too, like all of this will be covered because of this one, right, sir? And if I choose this, it'll cover these two edges and these two. So if I choose 3 of these, so I choose 1, 2, and this 3. So this is why it's number of 3, sir, because I chose 3 of them. Like this is covering 1, 2, 3, 4. And this is covering 1, 2, and 3, right? So I mean 1 and 2, and these two left uncovered. So these two are covering each other. So that's how we do, sir, like 1, 2, 3 caps.
Okay. So here is the number of cover is okay. So again, the case have to see with the case 1, case 2. What is that? Can you go to below?
Yes, sir.
So here is the second case is case 1 is the minimum number of cap. The first one, case 1 is the minimum number of cap, and the second case again number of caps such that employee assigned to.
So right now what I just did was case 1, right, sir? Like case 1, right, sir? And how do we do case 2, sir? Like when nodes represent employees.
So the first case is for the vertex cover. So it is not giving the correct answer with the case, what are the option is giving, no?
Yeah, case 1 gave the correct answer, right? So like the way I did it was all right? So like I chose these 4 for one cover, and these for another, and these 2 at the end. So this gave me 3 caps in total, which is actually the right answer, right, sir, for case 1. This is all right, no, sir? And so I did not understand like what I am supposed to do for case 3. Like the answer is the same, sir. I don't understand what I supposed to.
What is the both answer at the minimum number of caps? So correct answer is the only the cap minimum also. Okay. Can you post on Discourse? I will write the solution. That would be good because it's taking time and for me to understand that.
Oh, all right, sir. All right, sir. And also, sir, one more question, sir. I think it's a verbal question, sir. So I don't think it will take much time. Like over here, this is the question, right, sir? Over here, when right hand limit is equal to 2, like f of 2, but why is like the left hand limit not equal to 2, sir?
So you have to find separately, no, left limit.
I put 2 in both the cases, right, sir? Like both of them. Like first of
In
all,
both
I
cases,
factorize this.
function value is in both cases, function value is 1. But left limit and right limit is, what is the left limit is differ and right limit is different probably. So left limit is, how you can do the left limit is, finally you have to choose a such way that when you are doing, if it is the minus value is given, then minus of that in front of that you will write. So this problem is the solution, you can see, no, the left limit, and I think this is of the mock.
Yes, it's of the mocks. But the answers are given, but I like explanation is not given, I guess, right now. So.
No, and if you see the solution, in the solution you can see.
Sir, where is it exactly?
I just given in the solution, graded solution section, and also tomorrow we'll get from the below of the mock. Yes.
All right, sir. So when will you review mock tomorrow?
Just now, while the session when it started, I said already to the operational team, but they forgot to upload. That's why I given in the chat and also uploaded in the graded assignment solution section, so that tomorrow it will be below to the mock section. Where is the mock? Below of that, you will get the solution.
All right, sir. Thank you, sir. So that was all, sir, from my side.
Yeah, okay. You can stop, Siri.
Sir, shall I ask my doubts now?
Yes, so let me, someone else have doubt. Let me go with the one by one. Okay, just a minute. Where is that?
Because tomorrow also is college, so we just activity 11.10, 1, 2, 3, just these 3 questions.
But someone else, let me go with the, like, Sudhir is, sorry, okay, you are the next one. Sudhir, okay. So what's your doubt?
The activity question 11.10, question 1, 2, 3.
Okay. So let me present first my screen. Activity 11.1.
No, it's 11.10 based on Kruskal.
Okay. What's your doubt there?
Question 1, 2, 3.
So
can
again,
you start begins like?
Sorry.
I think now I would have answered. So maybe at that point of time I was not clear.
Yeah, because now what is remain now? Like 3-4 question I did on the Kruskal and
Yes, sir.
whatever.
This thing I can do, sir. Question 2 and 3.
What is 2? 2 is it is based on which of the following is correct. The minimum cost spanning tree of a graph is unique. The tree can be spanning. So this is the main the motto, right? The minimum cost spanning tree is the cost is unique. No, it cannot differ. I just said no. Either you go with the Kruskal or you can go with the Prims. Both give the unique or minimum number, of both give the same answer. It will not give the difference.
Sir.
So that's why it is going to be the minimum. It is going to be unique, no? Minimum cost spanning tree. And there can be more than one minimum cost spanning tree of the graph, because
the others I'm clear. So the third question.
So find the number of edges that are removed from the graph. Figure is 12.8. Where is that 12.8 figure? This one. Okay. What is going to be, find the number of edges that could be removed from the graph to obtain the minimum cost spanning tree. You can go with the right, whatever you are going to Kruskal remaining, right? Using here whatever the answer.
So the remaining is okay, sir. Got it.
Okay, next is the Sudhir. Sudhir is, I think, Sudhir were the next one. Shrest is the next one.
Sir, I had doubt in the graded assignment 11th.
Graded assignment?
11.
Did you gone through with the solution?
Yes, sir.
Okay, what's your doubt now?
Sir, the second question, graded assignment. How to do that? I don't know.
So if G is a connected undirected graph such that vertex has degree 8 at most, and the shortest path between any two vertices have the length of 2, then what is the maximum number of vertices in G? Try to draw the BFS tree starting with any vertex. So what's your doubt here?
Sir, I am not able to draw the BFS tree.
If G is a connected undirected graph such that every vertex had degree at most 8. So at most 8 is that. It could be 1, 2, 3 or 0 also. And
Yes, sir.
shortest part between any two vertices has length at most 2. So shortest path any 2 means at most 2. Okay. Then what is the maximum number of vertices in G? So just a minute, I have to see the solution first.
Sir, I also had a doubt in this question.
On the same problem, okay.
Actually, I also had a doubt. A few.
Sir, how important is adjacency matrix for this end term exam, sir?
Sir, sir, we can't hear you. Hello, sir. Sir, you are not audible.
We have to skip Bellman for the algo for the end term. Anyone know?
What did you say, bro?
Bellman for the algorithm.
Yes, sir. Bellman for
Yeah, like over there you don't have like negative cycles, like sum of negative cycles is not.
There are two methods, Dijkstra and Bellman. That both we have to skip.
No, only you can skip Bellman and Floyd Marshall.
I think the most
two.
important would be BFS, DFS, and minimum cost.
Sir said negative edge weights won't come in exam.
Yes,
So-
yes. Only minimum cost spanning tree and that first one, DJ, something like that. I don't know the name.
Yeah, like I did not see much questions from adjacency matrix in the PIQs.
More
Adjacency
from
matrix.
BFS and DFS.
Yes, BFS,
Yeah.
DFS, and mainly important in the sessions. The instructor were telling that mainly important was that vertex cover and minimum coloring and independent set.
I did not even like understand the adjacency matrix taught in the lecture. Like I did not understand that pretty much.
These types of edges are important.
In degree and odd degree types or directed on the
Forward, backward.
Yeah, that comes for like less marks, and that's pretty easy. So you can do it. It's
Sorry, am I audible right now?
yes,
Yes,
you
sir,
are,
yes.
sir. Sir, how important is adjacency matrix, sir, for example, for the end terms?
The end term means maybe question will be directly asked. If you have a given adjacency matrix, then how you'll find the graph? Find the graph, then related to that, find the something edges, vertices, or I don't. So maybe similar kind of thing.
The types
Or
of
maybe
edges
you have a
type
graph,
question
then
will
what is
come.
going to be adjacency matrix? Sorry.
Types of edges will come in end term.
Types of edges. What are the types of edges?
Sir, forward, backward, like.
Okay, those is may come because this is under the BFS, so may come. Okay, so let me take that problem. So okay. So whatever this one we have, no, with the DFS tree we can think. So here is you have to see if G is connected undirected graph such a way that every vertex has degree at most 3. So suppose U is a vertex, no? Am I audible?
Yes, sir.
So suppose
Yes,
U
sir.
is a vertex here. So at most, suppose any, I don't know what is the degree or how many vertices it have, but suppose U is a vertex in the graph, then the U have at most 8 vertices. So at most 8 vertices means like this, you can think it have 8 vertices. Okay. So suppose similarly, like this is one, suppose this is one, okay, this is one vertex. So similarly, other vertex U1, let's say this is V1, this is V2, V3, V4, like this, V3, V4, V5, V6, V7, V8, okay. Okay, and the shortest part between any two vertices has at most length have at most 2. That means now in the next, if you want to connect next vertices, then only one edge could be possible. Means here is, suppose here is now vertex 9. Here is vertex 9. Then no, now this vertex, this is the shortest path. The shortest path. Now the shortest path means vertex U to vertex 9. The shortest path is what? The length is at most 2. Length is now 2. You cannot suppose here is in between. You cannot, or even let's say here is another vertex V10. Okay. So between vertex U and V10, the shortest path is what? 3. So such thing will never happen. So that means here till here is the end one. The depth from U to any vertex is only 2. Or even if you think like this, here is okay. Suppose here is 1. So like this may be possible. Okay. This one. Okay. So for V1, so for V1, there is only possibility that for V1, either it could be done connected with all other, and it cannot grow too. It cannot. Okay, it cannot grow. Let me see once. Here is the word. It cannot grow to the next one. Like it will. It will grow to the next one. But after that, you cannot grow, because if you connect with the other, like I am saying here, if you connect with the other, so the longest path for V1 to V9 is going to be the 3. But longest path, shortest path is going to be at most 2. Length is going to be 2. Okay, so
okay, sir.
That means here, if it is like this is happening, the shortest path is with this one is going to be, okay, this is going to be only the direct one. Only the direct one is going to be. So it says if it is here is only 1, then it is always to be direct one. So that means here is, if you see here in the solution, so let me show you in the solution. Okay, where is that? In the solution, it says if it is going to be next one, then the each vertex could be like here. Now, for each vi can have at most k minus 1 adjacent vertices. Means if it is at most k minus 1 is for assuming to be k here. So it have for this one, it have only, if it is 8, so 8 is the at most 8 is there, then 8 minus 1, 7. It have only the 7 vertices. It cannot go because one is, because of this one is bound, and the long, because of the shortest path another bound is there. You cannot go with the next one. So that's why it will only connect with the next vertices only possible is, or adjacent edges will be only k minus 1, which is 7 minus 1 edges could be possible here. Here is, for each vi can have at most k minus 1 adjacent vertices, like here. For each vi only k minus 1 vertices could be possible. Otherwise, in depth you will go, it will be from here. If you start growing, then it cannot go, because now the edge is going, the shortest path for the next vertex is going to be 3. And here is one more condition, it's asking for tree only. I just forgot that, write to tree. Connected undirected graph such a way every vertex at most 3 and shortest path of any 2 is 2. Then what is the maximum number of vertices? Try to draw the BFS tree starting with any vertex. These are connected undirected graph such a every vertex has at most edge. So only it is asking for the, because tree has, tree is a kind of tree is a what, it contains all vertices. So in that sense, that this hint is given. So suppose, let me again tell you that suppose u is here vertex, okay, so it have at most n edges. So again, let me write here, let me again erase it. So it have at most 8 edges. So this is 1, this is 1, 2, 3, okay, this is 4, 5, 6, 7, 8. So it have at most 9 edges, 9 degrees. So it have 9 vertices, it would be connected. Now next is there, from v1 it is assumed, so only one is here because the shortest path is 2. For suppose here is this vertex is connected, okay, this vertex is connected. If like this, any vertices are connected, so it have at most what? It have at most, how many will be there? Because this is 1 and this is, if you count, this should be all 8. This should be all 8. So how many it will be? 7 only, because as more 8 is given. Similarly for this one, what? This is 1 and already 7 possible. So this is going to be 7. And why the next one is cannot grow? Because if you connect with another vertices here, okay, if you connect with that, so the depth is, see that the shortest path, so this one, and then this one is going to be 3, but we want only 2. So this cannot go beyond of it. So 7, then 7, for this one with again 7, for this one with again 7, 7, 7. So that's why, how many it could be possible now? How many it is?
7.
This is 6, 8, and then this 7, this 7, this 7, this 7. So by the form, what is the formula finally written in the solution? If you see that, k times, so k times, so level 2 of BFS tree can have at most k into k minus 1 vertices. The graph can have at most now 1 plus k plus k plus, right, 1 plus k minus 1, like whatever in this here, k times k minus 1. This one, and this is k, and this is 1. So finally added. So same word, 8 in place of k, you can write 8 now. Yes, no, or I don't know. Is that something you are getting? Because of the at most one and shortest path, it's truncated here, or it is a bound one. Is it clear?
Okay, sir. Thank you.
Once again, start thinking that how it is. Okay, please take your time and then think. Because of this condition is we cannot grow, we cannot add vertices because of the shortest path.
Sir.
Yes.
As per formula, it is going to 56.
So as a formula, you are no. It is a no.
But
It can,
physically, we see 56 plus 8.
this problem not going to ask. This is a much deeper problem, and
Okay. Thank you.
it is a kind of formula you are going to ask. Then how many formulas you will remember? Okay.
Okay,
Let me see with the next one. The next one, then DHB7. What's your doubt? I think we have removed DHB7. Oh, we have done. Sumit Shah. What's your doubt?
Yes. So question number 3 of this assignment only. Question.
Of this assignment. Question
Yes.
number 3 is this one.
Yes, sir.
So what's your doubt here?
So this A square is transitive closure. So this is not.
Suppose A is the adjacency matrix of the connected undirected graph. A square is not transitive closure. Just keep the A square, and the shortest part between any two vertices has length at most 2. So this A square actually tells you that no, it is an and word. The shortest part between any two vertices has the at most 2. Then which of the following may represent the graph? Okay, which of the following may represent the graph? So first thing is, it says the shortest path between any two vertices has at most 2. Using this one, you can neglect the options first. So see that the shortest path between this one and this one is going to be greater than, right, 2. This is 1, 2, 3. So first option cannot be. Now choose the next. This is one shortest path with respect to reaching to this one. Any other, if you choose, see this is going to be a kind of shortest path, but something we have to now you can choose with the option. Okay, this could be one possibility. Again, this one is again cannot be, because this one is again cannot be, because if you go with the shortest path with this one and this one, it is going to be shortest path is this one. Okay, shortest path for this one is 2. Okay, shortest path this one is going to be. Okay, so there is one possibility. So these two could be possible. Okay, let's do for the next one. Shortest path is okay. With the option wise we can go, no? And once you find the option wise, we can choose with the you need to find A and then A square for each vertices. So for each graph, you just need to find A and then find the A square. Like here is the solution is written, no? What I'm saying, is that clear?
Yes, sir. That A square confused me.
A square is confused. Sorry, A square is what?
We suggest adjacency matrix, but we just multiply matrix multiplication.
You have to do matrix multiplication, but yeah, operation, adding one,
Yes,
one
sir.
is how one will get. Adding 0, 1 is what? Multiplication, if you are doing, how you are getting the operation is different.
The row and column wise.
So can you do this one, sir, if you have time, sir? If you have time, only if you have time, can you do this one, sir, this question?
Sir, I also have just one question, sir. 11.8.
Almost I have explained. No, what is remain now? Nothing is remain. Why you want to tell me that? See, solution is there, and see, for each one, see, I have neglect this option as because of shortest path. For this one, you have to find the adjacency matrix and then square them. Which one is give the exactly this one? That is your answer going to be. That's all.
Oh, so understood.
Small doubt, sir.
Only the calculation part is remain. Okay, next one.
Question number 7 also.
Someone else have the related doubt here or something else?
Yes, sir. Small doubt.
So it's 11.8 question 2 and 3.
Just a minute. Let me, Dhanya, please stop. I am just asking someone else have with the same problem doubt.
Yes, sir. Small doubt, sir. How can we use this matrix A square given in this question, sir? How can we make use of that to get the solution?
How we can use?
Yes, sir. A square only, that is for checking it.
So once you found A square, here is A square is given, you can match with that.
Only for matching. Other nothing you can get.
Nothing, because a square is given.
Yes,
A
yes.
square is given.
Yes,
That
from a square we cannot revert back to a. Na? Only we will have to draw a
matrix
from the graph.
multiplication. In the matrix multiplication, once you study maths 2, there
Yes.
is the matrix multiplication. You cannot go back.
Only thing we can do that we can get the from the graph we can get a, we will square and we can match.
Then yes, then you have to find a square.
Okay, thank you.
Question number 7 also have doubt. Okay. What's your doubt here? Oh, this is already one solved with us, no? I think so, exactly. Am I audible?
Yes, sir.
Okay.
Could you just briefly explain?
I think briefly explain means here is, if you go with the solve with one means just you can erase this one. Okay, you just erase this one, forget about this, and start finding the shortest, or what is that? You start doing the Dijkstra algorithm. So, and it is done from the A. So Dijkstra algorithm says go with the minimum one. So
this
Sir, we have to
algorithm
avoid
question
the
will come.
variable because we don't know if it is great less than or equal to 3.
Sir, isn't it supposed to be like 4 plus 3 plus x should be greater than 0 since it cannot be a negative cycle? Sir, we cannot hear you just in case.
am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
What is happening? I just got disconnected. Okay, so I will here. Where is that? Where is that? I think here. Okay, so I think so.
Yes, 7.
And
It should
also
be less
that
than
time
7 for it.
explained right now.
Yes, sir, it should be less than 7. Yes, sir, I got it.
Just now I explained the Dijkstra algorithm. No, you start from A, then if you want to reach B, if you go with this path, this gives 6, but it reaches directly here B, then with the weight 2, then minimum 1. So here is just you can remove this edge because this is X unknown is given. Okay, by this way you go, by this way you go, and then minimum 1 is this way, and then this way, this way. You will see that there is the 13 is written. Okay, 13 is says now if you connect, you want to go with the minimum one. If you add this h, because now if other way if you go, it give maximum. It will give greater which you need to add. If you add here, then it may give minimum. So now you can add here. So how this age, this much age, whatever the weight is here, if you remove that, it will give the minimum one. Am I audible? I don't know.
Yes, sir.
Yes, sir. Yes, sir.
Okay, or by this here solution, if you see that here x, here is x, assume 2 plus x and minimum 1, here is 3 plus x, and by both way it is written by this way and this way. Here is in the bracket it written as minimum of 2 plus x directly, or comma 9, the main value, like this one, and then this one, and similarly the minimum of this one and this is the minimum are written. Now 13 is there, and this is 6 plus x is there. How will give the minimum? If we assume some value, give some value is here. Which value is give the, if it is less than 6, then it give the 12. Okay. Here is something is more. This is 6, 9, 8, and 6. Find the value of x. What is the option is here? Find the set of all positive integers of such that if you use Dijkstra algorithm, then we will be a unique shortest path from the vertex A to vertex J that contain the HBE. So all possible, no? All possible. Here is the value of all possible. Even 6.5 will also work. So that's why the value is 7 for it is given.
Sir, why 7 not included?
Sorry, yes. Why 7? Am I audible?
Yes, sir. Why 7 not included? Because it will be the same like weights, right?
But 7 is not included. The reason is find this all possible of such that if you use Dijkstra algorithm, then there will be a unique shortest path from A to J which contain B and E. Okay, why it is not unique?
Sir, because in this algorithm, we have to always find the shortest path. So including 7, it will be, I think it will be more than 13. So that we have to
yes
exclude.
Sir, it will burn late.
No, it is, and also it is not 13 exactly. It is not exactly 7. The reason is the minimum one we want. I think. Okay, just a minute. I think in the question, what is that? 7th. Then there will be a unique shortest path from A to J, which contain B and E. Okay, unique. Oh, so the word is uniqueness, no? Because of uniqueness. I'm just missing that. I just missed the uniqueness. So if you go with the, if you include 7, okay, if you include 7, so you have 2 shortest path, not unique. Okay, one is what? One is this one, and another is this one. But it says unique shortest path. So that's why unique one is what? This one, right? Only by this way. That's why it is lesser than 7.
Yes.
Is this clear?
Yes, sir.
Okay. Who is the next one? No one is here. Okay.
Sir, my doubt, sir. Activity question 11.8, question 2 and 3.
11.8,
11.8, sir. Question 2 and 3. So just want to know. So for 11.8 question 2, we have to make sure that all the edges are there, but vertices have to be the same, right?
Yes, yes.
So, but how to find out the third question?
This is only by, you have to, right? You have to go with the manually. Only
Like,
way
is
to.
there any formula and also?
No, there is no formula. Manually you have to go.
Okay, sir.
Okay.
So
Okay.
tomorrow also we can clear our doubts, right?
Yeah, TA will take at evening.
Okay, so will there be a session with you, sir? Like when it's on?
No. Now the revision is done. So TA will, the last tomorrow is going to be the last session with the TAs.
So like, is it possible to give you the email, sir? So if any doubts, I can message you. Email
So
you
you
at
can
least.
post, you can post in. So email means you have the already discourse and discussion forum, and also
Okay,
TAs.
sir. Okay, sir.
Okay. Okay, thank you so much. And now
Sir,
I'm going to end the session because it is.
Sir?
How many doubts all of you have? Okay, so
Should I present my screen?
in the back. Okay, what's your doubt? Sorry. Yeah, you can ask.
I'm
No,
I'm
just
presenting
while
my
telling you can itself. What's your doubt?
in the mock test end term mock test, question number 1 and 2.
So it is solution is already given, no? I have given the solution.
Solution is not there. Mock test end term.
So what is that? You are not getting the questions, or you are not getting the concept, or you are getting the different answer?
Actually, I'm not getting the concept, how I can proceed to solve that. It's a quadratic equation.
This one, this is the problem. This is the problem for me. This is the mock problem.
That in my mock test, I'm getting some other question.
Okay, then maybe with the different mock, with this problem, maybe this one. Okay, this is the same one.
It's a parabola, two parabolas, downside parabola.
Okay, the mock is the same. I don't know. This is in the randomized form. Okay, so what's your doubt? Like what is the problem? You can tell, because
How
present.
see, they have not given the f of x function of slope of the parabola, and they have just given the two parabolas, downside parabolas, and the length and height of that direction and height. Should I share my screen?
Okay, you can share your screen.
Yeah. Could you please? Yeah. Are you able to see?
No, just a minute. Yeah. Yes.
So this is the question.
So what's your doubt here?
Here, I mean, they have given this. D is the origin, is 0,0, and here 0,30, and vertex will be 15,15, right? So how I can generate the equation slope of this curve?
So can you go with the option wise? Like if you have
Yes,
some
I
quadratic
was.
equation, you have some quadratic equation, using that you can find the with the what is going to be the here 30 it will give, or maximum height it will give.
agree. As per our E comma X will be
Your voice is breaking a lot. Your voice is breaking a lot for me or all of you, for all of you.
All of us, sir.
It's okay.
No, still your voice is breaking a lot. Okay, so to find this one, no.
Please help me.
So to find this problem, like to find the solution, find out the equation of the curve followed by the firework. Which one is the firework curve? Firework is a projected.
This is B2.
Which one is the firework curve? Is
B to 30.
B to 30. Okay, so this is so minus B by 2 is the maximum height, and the next is how you can find the, like you can use the minus B by 2A for the maximum height, and range is there. So which have the range is, or the using the roots, no? So that 0 is one and 30 is the another root. So which have the root will give, right? So 0 is one.
I can calculate A, B, C.
Sir, I had a different approach to this, sir.
So somebody can tell, that would be good. So what's your approach?
Sir, I had a different approach to this, this
Yes,
question,
yes.
sir.
Yes, how
so
are
instead of taking the long way out, since we are already given the coordinates, for example, for the firework, we are already given the maximum point 15 and 15, right, sir? Like we are just given the y coordinate 15, right?
Yes.
So when I plug that into the equation, so for example, if I plug that into any of the equations and where I get the x as near as 15, then that would be my correct one. So that's the approach I took, and I got the right answers from both.
Okay, yeah, that is the tangent, no? Okay, so one
And
tangent.
also, sir, so I also had one more problem that was like similar to this, but over there when I used this approach, I wasn't able to find the answer. So can you do that question after you solve this, sir?
So that is a better way. Can you post in the discourse, because it's a more longer time I'm doing it here.
Oh, all right, sir. All
If
right,
you have,
sir.
you can post in discourse. I can do there.
So what is discourse actually, sir? Like, where is
So
discourse?
you are the first time you are writing this.
Oh, discuss. Oh, discuss forums. So okay.
So if you are first time writing, then you will find the Google group. Or if you are term student, means you are already clear your qualifier one term back, and then register the course, this math one, then you will go with the discourse.
Oh, all right, sir. Thanks.
So see that I don't know your name is Dijkstra and something. Sorry, Dhanvantari. Yes, so you see, use the concept of tangent, because one pole tangent is given, something is there. Use the concept of tangent, like at 0 and minus b by 2a max for the maximum height, and also using the root. Using these three concepts, because that curve have two root, no, one is 0 and another root is 30. So choose the option which will give the root 0 and 30. Choose the option which have the maximum height, and choose the option which have tangent exactly the line y-axis line. Like this you can think, and you can choose the correct options using these three concepts. Is that clear?
Are you giving solutions for these?
If you post in the discourse, I will be better. I will give the answer in the written form also. Okay. Okay. Yeah, thank you so much. Now I'm going to end the session.
Thank you so much, sir. Good night, sir.
Thank you so much.
Thank you, sir. Thank you, sir.